Hey, champs of Examsnet. You're welcome to our website, www.examsnet.com. You're already aware of it. So do visit our website to explore this question papers PDF and many more entrance exam question papers PDF, similar type of, so that you can practice even more. You can also download our app. You have the link in the description box. So in this paper, today we'll be solving TS EAMCET 20 July 2022 Shift 2 paper. We'll be solving the mathematics portion of that paper. You're having different portions, and we'll be keeping our focus on the mathematics question in this paper. Let's start with that, students. A very best of luck. Here we go. Question number 1. It says, if this represents the greatest integer function, then the set of all real values of x for which fx is equal to this is real is. Right. Okay, you are given the function to be, let's write it down, greatest integer of x minus x upon x minus this. So here one thing, x cannot be equal, cannot belong to integers. Any guesses why is that? Yes, because if x will belong to the integers, then the function will be of the intermediate form. Function will be of intermediate form, that is 0 upon 0, which is not possible. So that means for x to have non-integer values, we can write down fx as, I'll take minus common from the numerator. So x minus greatest integer function of x, x minus greatest integer function of x, and of course they will cancel out and you will have minus 1 in the root. That is your fx. So that means for x to belong non-integer values, fx is not real. This is imaginary. Root 1. This is actually iota. So this is imaginary. That is not real. So that means x will belong to, that means x will belong to null. So we have option A as the answer, null set. Hope you understood this. Next is question number 2. If this denotes the greatest integer function, greatest integer less than x, then the range of the real valued function this is. Okay, so you are given this. Let's write down the function first. Fx is equal to 1 upon root of x minus greatest integer x this. And we know x minus greatest integer x will be equal to some set of x. And x lies between 0 and 1. The set x lies between 0 and 1. Therefore, fx can be written as this, right? This lies between 0 and 1. That means the root of it will also lie between 0 and 1. Okay, let's take the reciprocal on all the sides. That is 1 upon 0 is greater than 1 upon. See, the sign will change, right? I'm reciprocating it, so the sign is going to change. So this is 1 upon 0 is greater than 1 upon the set x is greater than 1 upon 1. You know, this is equal to infinity, and this was your function x. So that means fx lies between infinity and 1. You can write it as fx belongs to 1 infinity. That is option C. This is the answer to the question. Hope you understood. Next is question number 3. If A is 2 by 2 matrix such that determinant of A is minus 21 and trace of A cube is 2024, then the trace of A is equal to what? Okay. So A's determinant is 21 and trace of A cube is 2024. So let's say we are given it's a 2 by 2 matrix. Let's say A is A, B, C, D, this matrix. Let's find out A square. This will be A, B, C, D multiplied by this. So this is equal to A square plus BC, AB plus BD, AC plus DC, BC plus D square. Now A cube will be A multiplied by this, A, B, C, D multiplied by A square plus BC, AB plus BD, BC plus D square. So this will give you A cube plus 2ABC plus BDC, A squared B plus ABD plus B square C plus BD square. A square C plus ADC plus BC square plus D square C. And here is ABC plus 2BCD plus D cube, right? So let's find out the determinant of A. You are given that is equal to minus 21. Determinant of A, you know, A is ABCD. So determinant of A is AD minus BC is equal to minus 21, right? Now, trace of A cube. That is equal to A cube plus D cube plus 3ABC plus 3BCD. You know what is trace of a matrix? Sum of the diagonal entries. Okay, that is a trace of a matrix. So this is given to you as 2024. So now putting BC is equal to AD plus 21. So you can write it as A cube plus D cube plus 3A AD plus 21 plus 3 AD plus 21 into D is equal to 2024. So this will be A cube plus D cube plus 3A square D, okay, plus 3AD square plus, I'll open it first. This will be A cube plus D cube plus 3A square D plus 63A plus 3AD square plus 63D is equal to 2024. Now, this will be A cube plus D cube plus 3A square D plus 3AD square plus 63 A plus D is equal to 2024. Okay, so look at this. This is the formula for A plus D whole cube plus 63. A plus D is equal to 2024. I'll take A plus D common. A plus D square plus 63 is equal to 2024. So trace is equal to A plus D. right? This was the trace of a cube and this is a trace of a. You know, a was equal to a, b, c, d. So trace is equal to summation of a and d. Okay, now I'm considering these two. I have to actually, in the question, we are asked what is the trace of a. So a plus d, if I find out this value, then I can find out a plus d is equal to. So let's say a plus d is equal to some x, right? So this equation, this will become x into x square plus 63 is equal to 2024. Now 2024, this is a big number, right? That means I can't go with one or two values in the first thing. I'll try with the 5. Okay. See, 5 also I can't try. Why? Because this will be, then this place would be 5 or a 0. So 5, x is equal to 5 is also not possible, right? Then the units place over here will be either 0 or 5. But this is not there. It is a 4. So I'll try with 6 then. Let's say x is equal to 6. So this will become 6 into 36 plus 63. That should be equal to 2024. So that's equal to 6 into 99. This is equal to 594. That's of course not equal to 2024. So see, there is still a lot of difference. So let's jump quite good numbers now. Again, let's say put x, which was actually equal to your a plus d. Let's put that equal to 11. So this will become 11 into 11 square 121 plus 63, which will be 11 into 184. 11 into 184. This is equal to 2024. So we got our answer. The end part will be hidden trial method only. Okay. So we have 2024. Sorry, we have a plus d is equal to 11. This is what we needed to find out. Trace of a was equal to a plus d, and that came out to be 11. That means option B is the correct answer to the question. Hope you understood this. Next is question number 4. If this is a skew-symmetric matrix and B, C, F are non-zero real numbers, then B upon C is equal to what? You're given that A is a skew-symmetric matrix. That means A's transpose is equal to this, negative of A. So let's do the transpose of it. This is A, B, C, D, E, F, G, H, and I. This is equal to negative of A, B, C, D, E, F, G, H, I. Okay. That gives you, see, on comparing the elements, what did you get? Let's write it first. A, B, C, D, E, F, G, H, I is equal to minus A, minus D, minus G, minus B, minus E, minus H, minus C, minus F, minus I. So on comparing, we have A is equal to minus A. That simply gives you A is equal to 0, right? Also, E is equal to minus E, which gives you E is equal to 0. I is equal to minus I, which gives you I is equal to 0. These three things. Next, you have D is equal to minus B. G is equal to minus C. B is equal to minus D. Then H is equal to minus F. C is equal to minus G, we have from here also. Also, F is equal to minus H. So on comparing both of them, we got these values. Let's name them as 1, 2, 3, 4, 5, and 6. Now, let's divide equation 3 by equation 5. Equation 3 by divide equation 3 by equation 5. So you have B upon C is equal to minus D upon minus G, which gives you B upon C. You can write it like this, minus D upon G into minus 1, right? Let's say this is equation 7. Okay. So now let's divide equation 3 by equation 4. You have equation 3 by equation 4. Equation 3 by I'll skip this there. See, what we need to find out, actually, we need to find out the BC in the question, right? BC is equal to D minus D upon minus G. That is equal to D upon G. But D upon G is not in the option. But you have something like this. D upon G, like it's multiplied with something also. So I just need to pick up this minus 1. And this minus 1, I can pick up from here. See, over here, you are having F and H in all the options. So I'll pick up the sixth option only, sixth one, that is F is equal to minus H. You can have F upon H is equal to minus 1, right? Or you can also say H upon F is equal to minus 1. Both will go, right? So now I will replace this minus 1 with either of these. Okay, let's see. So B upon C will be equal to minus D upon G into F upon H, or minus D upon G into H upon F. So that is, it is equal to minus DF upon GH, or minus DH upon GF. Let's check which of these is present in the options, DF upon GH or DH upon GF. This is DH upon GF is there, but I need the minus. Minus sign is missing. So option A is incorrect. B is also incorrect because minus sign is not there. So you have DF upon DGH. That's true. Also, DH upon FG, that is also true. Question number 4. If this is a skew-symmetric matrix and BCF are non-zero real numbers, then you have to find out the value of BC. You're given this matrix, let this be A. You are given it is a skew-symmetric matrix, which means the transpose of the matrix is equal to minus of that matrix. What is the transpose of this matrix? A, B, C, D, E, F, G, H, I. This is equal to minus A, minus B, minus C, minus D, E, F, minus G, minus H, and minus I. So on comparing the corresponding elements, you get A is equal to minus A, which means A is equal to 0. Then you have E is equal to minus C, that gives you E also equal to 0. And then you have I is equal to minus I, which gives you I is also equal to 0. So these three, A, E, I, they are equal to 0. Now comparing them further, you will get D is equal to minus B, G is equal to minus C, B is equal to minus D, and H is equal to minus F, C is equal to minus G, and F is equal to minus H. Let's name this and number them as 1, 2, 3, 4, 5, and 6. Now you want B upon C, right? That means let's divide equation 3 by equation 5. So equation 3 by equation 5. You will get B upon C is equal to minus D upon minus G. That's it. But I don't have minus D upon minus G in any of the options. Rather, I have D upon G in all of them. Right? Plus, I have F and H variables also. So I have to introduce them as well, F and H. And those, both the variables are lying in equation 6. So equation 6, you can have F upon minus H is equal to 1. Or you can write F upon H is equal to minus 1. This can also be written as H upon F. So F upon H or H upon F both are equal to minus 1. Now I can write down this as minus D upon G into minus 1. And this minus 1 was equal to f upon h or f upon h. One more thing is there. Here, if h is equal to 0, see, over here, it's given that BCF are non-zero real numbers. That means h may be equal to 0. So if h is equal to 0, then f upon h is not defined, right? So this is not possible. So I'm left with only the possibility of h upon f is equal to -1, right? So I can write down this -1 as h upon f minus d upon g multiply h upon f. So this will give me minus dh upon gf. That's equal to BC. This is what we needed to find. So we have option D as the answer. Minus dh upon gf or fg. Option D is the correct answer. Hope you understood this. Next is question number 5. Again, a matrix problem. In this matrix, if the cofactors of -6 and -7 are respectively are this, then you have to find out 5x plus y is equal to. So basically, you have to find out the value of x and y, and then I'll find out the given expression. You are given that this is the matrix, cofactors of -6 is equal to 22. What are the cofactors of -6? Let's write it down. -1, x, -7, and y, right? So this is the second row, third column. So -1 will also be introduced. Okay, -1, 2 plus 3, because it's second row, third column. So this is equal to -1 into this. So cofactors will be given by -1 into -1 y minus of -7 into x is equal to 22, which will give you y minus 7x is equal to 22. These are the cofactors of -6. Similarly, the cofactors of -7. This is equal to 27. So 7 is lying in the third row, first column. This will be given by -1, third row, first column. X, 3, -5, -6. So this will be equal to x into -6 minus 5 into 3 is equal to 27 minus 6x plus 15 is equal to 27, or minus 6x is equal to 12. X is equal to -2. I'll fill this in this equation. Let it be 1. So let's fill this in equation 1. You will get the value of it was y minus 7x is equal to 22. So this becomes y plus 14 is equal to this, which gives you the value of y to be 8. You had to find out 5x plus y. So 5 into -2 plus 8, it gives you -2 as the answer. So we have option C as the correct answer. Hope you understood this. Next is question number 6. Consider the simultaneous linear equations beta x plus alpha y minus z is equal to -1. 3x minus beta y plus alpha z is equal to 0. Alpha x plus beta y plus z is equal to 1. In the usual notation used in Cramer's rule, given that delta 1 upon delta is this, delta 2 upon delta is this, delta 3 upon delta is this, then you have to find out alpha beta. First thing, these are the 3 equations which are given to you. Note these equations 1, 2, and 3. Now you're given that delta 1 using Cramer's rule, delta 1 upon delta is equal to -1. You know this is equal to x. Therefore, this is equal to x. So therefore, x is equal to -1. Similarly, delta 2 upon delta, this is equal to, you are given 1. And this is also equal to y. So y is equal to 1. Delta 3 upon delta is equal to 2. That means z is equal to 2. So I got the values for x, y, and z. So let's take the 3 equations now. From equation 1, you have minus beta plus alpha minus 2 is equal to -1, which gives you alpha minus beta is equal to 1. So let's name it as equation 4 from 2. Second equation, minus 3 minus beta plus 2 alpha is equal to 0. 2 alpha minus beta is equal to 3. Let's name it as 5. From equation 3, you have minus alpha plus beta plus 2 is equal to 1, or minus alpha plus beta is equal to minus 1. Let's name this as equation 3. So now solving equation 4 and 5, you will get 4 and 5. That was equal to alpha minus beta is equal to 1. Okay. So alpha minus beta minus 2 alpha plus beta is equal to 1 minus 3, which gives you minus alpha is equal to this, or alpha is equal to 2. Now putting this in equation 4. After I put this in equation 4, you will get 2 minus beta is equal to 1, which will give you beta is equal to 1. You have to find out the alpha comma beta. 2, 1 is the answer. Hope you understood this. 2, 1 is option B. Option B is the correct answer. Hope you understood. Next is question number 7. Again a matrix problem, but now the complex numbers are also involved. I have the iota over here. So determinant of this matrix is equal to x plus iota y. You have to find out the value of x plus y. Let's find out the determinant. I'll go directly. This is the given matrix: 2 plus 3 iota, iota, 1 minus 2 iota, and minus iota. Let's take out the determinant. This is given to you as x plus iota y. That's minus iota 2 plus 3 iota minus iota 1 minus 2 iota is equal to this, which gives you minus 2 iota minus 3 iota square minus iota 2 iota square is equal to x plus iota y. That's minus 3 iota minus iota square is equal to this. Iota square, that's equal to minus 1. So that makes 1 minus 3 iota is equal to this. On comparing the real and the imaginary parts, comparing real x is equal to 1. Y is equal to minus 3. Right? We got the value of x and y. What we need to find out is x plus y. So let's add both of them. You will get minus 2 as the answer. Let's check with the options. Option A is the correct answer. Hope you understood this. Then let's move to the next question. Question number 8. If alpha and beta are the roots of this equation, then alpha raised to power 2020 plus beta raised to power 2020 is equal to what? The equation is x square plus 2x plus 2. So I'll keep plus 1 over here and minus 1 over here. There's a reason for this, because this becomes a square of x minus 1 whole square. This is equal to minus 1. So mathematically, this is not possible. Square of any number cannot be equal to minus 1, negative number. So that means we have an introduction of the imaginary numbers over here. X minus y is equal to plus minus root of minus 1. That is equal to plus minus iota. That's equal to root of minus 1, correct? Yeah, that makes x is equal to 1 plus minus iota. So there are two possible values. Roots, actually, you can say. So alpha over here is 1 plus iota and beta 1 minus iota. These are the two roots. You have to find out alpha raised to power 2020. Let's solve it here. And also beta raised to power 2020. But before that, I would like to say just iota alpha square. There's a reason for this. You'll just come to know. So alpha square can be written as 1 plus iota whole square. Similarly, beta square can be written as 1 minus beta whole square. That's equal to a square. That's 1 plus b square plus 2 iota a square plus iota square minus 2 iota, that's equal to beta square, right? You know iota square is equal to -1. So these two will cancel and you will have alpha square is equal to 2 iota and beta square is equal to -2 iota. Now let's come back to our problem. We had to find out alpha raised to power 2020, that's equal to 2 iota raised to power 2020. Similarly, beta raised to power, sorry, here's a correction. See, alpha raised to power 2020, this is actually equal to alpha square raised to power 1010. Okay. So this can be written as 2 iota raised to power 1010. I hope you understood, right? Alpha square and this is 2 iota. So alpha square raised to power 2020 can be written as alpha square raised to power 1010. Now this is equal to 2 iota raised to power 1010. So now beta square, similarly 1010 is equal to -2 iota and 1010. Correct? Now I have to just solve this portion because alpha raised to power 2020 is equal to 2 raised to power 1010 iota raised to power 1010. And here beta raised to power 2020 can be written as, now this will be 2 raised to power 1010 iota raised to power 1010. Minus sign will go away because the power is even. You have to find out alpha, like you have to add both of them. So you will have alpha raised to power 2020 plus beta raised to power 2020 is equal to 2 raised to power 1010 alpha raised to power 1010 plus alpha raised to power 1010 1010, 2 into iota raised to power this. So that becomes 2 raised to power 1011 multiplied by iota raised to power 1010. So iota raised to power 1010, this can be written as iota square raised to power 505. Iota square is equal to -1. So this is equal to -1 into a negative number. Sorry, the power is into, sorry, this is 2 raised to power 1010 multiply -1 raised to power 505. This is a negative number. So that makes 2 raised to power 1010 multiplied by -1. So minus 2 raised to power 1010. This is the answer to the question. Option B is the correct answer. Hope you understood this. Let's understand it once more. So this was the given equation. According to the equation, the two roots which were possible were alpha is equal to 1 plus iota and beta is equal to 1 minus iota. You have to find out alpha raised to power 2020 plus beta raised to power 2020. First of all, I solved for alpha square and beta square. On solving, you get the value of alpha square to be equal to 2 iota and beta square to be equal to -2 iota. So alpha raised to power 2020 can be written as alpha square raised to power 1010. That is equal to 2 iota raised to power 2010. Similarly, b raised to power 2 raised to power 1010 can be written as -2 iota raised to power 1010. So that gives, I'll take 2 raised to power 1010 common and you will be left with iota raised to power 1010. Similarly, this will be the value of beta raised to power 2020. Adding both of them, you will get this as the answer. So we have option B as the answer to the question. Then let's move to the next question. Hope you have understood this well. Question number 9. You are given that Z, which is a complex number, is equal to this. Let's write down. Z is equal to -1 minus iota root 3 upon 2. Then you have to find out summation from k is equal to 1 to 2022 z raised to power k plus 1 upon z raised to power k whole square. Okay, so this is equal to omega square. You know that. So that means z is actually equal to omega square. And if I'm writing down z raised to power k, z raised to power k will be omega square k. That means it's omega 2k. Now, z raised to power k plus 1 upon z raised to power k can be written as omega raised to power 2k plus 1 upon omega raised to power 2k whole square, because see in the question I have a whole square also. So let's open up. This is a square, that makes omega raised to power 4k plus 1 upon omega raised to power 4k plus 2, right? Now this is see 3k into omega plus 1 upon 3k into omega plus 2, which makes it, see, this is, omega cube is equal to 1. So that means this is omega plus 1 upon omega is plus 2. All right. Right. So this is the value. Now you have to find out. Question number 9. If z is equal to this, that represents a complex number, then summation from k is equal to 1 to 2022 z raised to power k plus 1 upon z raised to power k whole square is equal to. So you are given z is equal to -1 minus iota root 3 upon 2. This is equal to omega square. So that means z is equal to omega square. Now take this expression z raised to power k plus 1 upon z raised to power k whole square. That makes z raised to power, omega raised to power 2k plus 1 upon omega raised to power 2k whole square. That is equal to a square, which is omega raised to power 4k upon plus 1 upon omega raised to power 4k plus 2. So this is omega raised to power 4k plus, this can be written as omega 2k upon omega 6k plus 2. Now, this can be written like this, 3k plus k, and I'll not touch this, let it be like this. So this is equal to omega cube raised to power 2k plus 2. Omega raised to power 3k, omega cube is equal to 1. So that makes it omega 1 into omega raised to power k plus this upon 1 plus 2. So that means this is equal to omega raised to power k plus omega raised to power 2k plus 2. That was z raised to power k plus 1 upon z raised to power k whole square. Now you have to find out, in the question you are given that you have to find out summation from k is equal to 1 to 2022 z raised to power k plus 1 upon z raised to power k is equal to 2. That is equal to summation k is equal to 1 to 2022. This plus this plus this. So see, over here you can write down omega raised to power k. So this will be omega plus omega square plus omega cube till omega raised to power 2022 plus omega square plus omega raised to power 4 plus omega raised to power 6 till omega raised to power 4044 plus 2 into omega plus, 1 plus. One plus 1 plus 1 till 2022 times. Now, see, this is forming a GP with A as omega and R also as omega. This is geometric progression series where the first term is omega and the ratio, the common ratio is R, that is omega as well. That the formula is given by A. I'll just write down the formula over here. The formula for the summation is of the GP is A into R raised to power R n minus 1 divided by R minus 1. So here R is omega, A is omega, R is also omega, N is 2022 minus 1 upon omega minus 1. Similarly, this is also a GP with the first term. Here the first term is omega square and the common ratio is also omega square. The formula will remain the same. So this can be written as omega square raised to power 2022 minus 1 whole divided by omega square minus 1 plus summation 2. See, this is equal to 2 into 2022. Correct? So now, if I take omega raised to power 2022, this is equal to omega cube raised to power 674. Yes. So this is, that means this is equal to 1. 1 raised to power 674, that is equal to 1 itself. So omega into 1 minus 1 upon omega minus 1 plus omega square. See, similarly, this is also equal to 1. So 1 minus 1 upon omega square minus 1 plus 4044. That will be 0 plus 0 plus this. That means 4044 is the answer to the question. That is, we have option C as the answer. Hope you understood this. Let's move to the next question, number 10. Statement 1. The set of solutions of x square mod minus 4x mod plus 3, here is mod, plus 3 less than 0 lies in this interval. Statement 2 is, if x is less than 3 or greater than 5, then this whole expression is greater than 0. Okay. So I'll pick up the statement 1 first. This is mod of x minus 4 mod of x square minus 4x plus 3 is less than 0. Now, two things are there. X can be positive. Okay, I'll write it here. And negative. When x is positive, this expression will be x square minus 4x plus 3 is less than 0. And when it is negative, it will be x square plus 4x plus 3 is less than 0. So the two factors will be, in this case, x square minus x minus 3x plus 3 is less than 0. So x into x minus 1 minus 3 x minus 1 is less than 0. The two factors are x minus 3 x minus 1 less than 0. And over here, the two factors will be x square plus x plus 3 x plus 3 less than 0. X plus 1, this less than 0. So the two factors are x plus 3, x plus 1 is less than 0. So here, if you see, this expression will be positive when it is greater than 3 or less than 1 on both the sides, but it will be negative between 1 and 3, right? So you can see it yourself. If it is between, like suppose it is 2, this expression will be negative. And for less than 1 and greater than 3, it will evaluate to be positive. So that means x belongs to 1, 3 interval over here. And in the second case, x belongs to, this is the one. So if I take minus 3 and minus 1, these are the two factors, minus 3 and minus 1. So on the right side, it's positive. On the left side, it's positive. In the middle, it is negative. So that means x belongs to minus 3, minus 1, union 1, 3. Okay. If I, sorry, I'll write it later. First of all, I'll just talk about this one. So here x belongs to minus 3, minus 1. If I combine both of them, so x will belong to minus 3, minus 1, union 1, 3. This is what x belongs to. But in the question, it is said that it lies in the interval minus 3, 3, which is false. So that means statement 1 is incorrect. It is false. Let's go with the second statement. It's x squared minus 8x plus 15 is greater than 0. If x is less than 3 or greater than 5, then this is greater than 0. Okay, let's find out the interval for this also. The factorize it, the splitting the middle term, you have x squared minus 3x minus 5x plus 15 is greater than 0. So the two factors will be x minus 3 and x minus 5. They are greater than 0. That means the interval will lie between 3 and 5. Right? Minus and a plus over here and a plus over here. Okay, so it is positive on the left side of 3 and the right side of 5, and in the middle it's negative. That means this statement 2 is absolutely correct. So you have statement 1 to be true and statement 1 is false and statement 2 is true. That is option B is the correct answer. Hope you understood this. Next is question number 11. So if 6x minus x squared plus 12 attains its extreme value beta at x is equal to alpha, then you have to find out the value of beta. Okay, so 6x minus x squared plus 12 attains its extreme value beta at x is equal to alpha. Let's say y is equal to minus x squared plus 6x plus 12. I'll take minus common, x squared minus 6x minus 12. So let's split in the middle term. No, I'll not split it currently. So I'll say x squared minus 6x plus minus 9 minus 12. So y is equal to minus x minus 3 square minus 21. That gives you y is equal to 21 minus this. X minus 3 whole square, right? This is the value we got. You can write it as y minus 21 is equal to minus of x minus 3 whole square. Let's make the curve for this. So somewhat like this. So let's say this is the extreme value. Okay. Fine. So it is saying you attains its extreme value beta at x is equal to alpha. So you have x minus 3 square is equal to minus y plus 21. This can be written as minus y minus 21, right? So x minus h square is equal to 4p y minus k. Here the vertex hk. So if I compare, h is equal to 3 and k is equal to 21. That means x is equal to 3 and for y to be the maximum. So alpha is equal to 3 and beta is equal to 21. Beta is equal to, can be written as 7 into 3. That means 7 into alpha. 7 into alpha. So that's the value for beta, 7 alpha. That is option A is the correct answer to the question. Hope you understood this. Let's move to the next question. Question number 12. Let alpha be the common root of this equation and this equation. And where lambda is equal to 0, you have to find out the value of lambda. First equation given to you is x cubed minus 2x minus 25 lambda is equal to 0. If I take this equation in terms of lambda, this becomes lambda is equal to x cubed minus 2x upon 25. And the second one is 3x cubed minus 8x minus 175 upon 3 lambda is equal to 0. If I make the lambda subject of formula in this as well, so lambda will come out to be 9x cubed minus 24x upon 175. So see, both of these are lambda. That means 1 and 2 are equal. From 1 and 2, you have x cubed minus 2x upon 25 is equal to 9x cubed minus 24x upon 175. On solving, this will cut at 7, right? You have 7x cubed minus 14x is equal to 9x cubed minus 24x. That gives you 10x is equal to 2x cubed. So this can be written as x cubed minus 5x is equal to 0. X minus 5 is equal to x square minus 5 is equal to 0. That means x can be equal to 0 or plus minus root of 5. These are the two possible values. So let's take x is equal to 0. If I take x is equal to 0 from equation 1 and 2, so I'll pick up this one. If I take x is equal to 0 in equation 1, lambda will also be equal to 0. From equation 1, lambda will also be equal to 0. See, in the question you are given that lambda is greater than 0, so this is not possible. I'll take the second one. X is equal to root of 5. So again, from 1, you have first equation. I'll take the equation directly over here. Okay, so this will be root 5 cube. Let's see the equation. Minus 2 root 5 minus 25 lambda is equal to 0. This makes 5 root 5 minus 2 root 5 minus 25 lambda is equal to 0. 3 root 5 is equal to 25 lambda, or lambda is equal to 3 root 5 upon 25. That makes the value of lambda is equal to 3 upon 5 root 5. Now let's take x is equal to minus root 5. So the whole expression now will be minus root 5 whole square. It was minus 2x. So minus 2 into minus root 5 minus 25 lambda is equal to 0. Minus 5 root 5 plus 2 root 5 minus this. So that makes is equal to 25 lambda, or lambda is equal to minus 3 upon 5 root 5. So these are the two possible values for lambda. 3 upon 5 root 5 or minus 3 upon 5 root 5. Let's check with the options. Minus option is not in the given in the option. So we have option C as the answer. Hope you understood. Next is question number 13. If the sum of two roots of this equation is 0, then which of the following is true? The given equation is x cube minus 7p x square plus 5qx minus 6r is equal to 0. So the sum, so this is a cubic polynomial. The sum of two roots of the equation. According to the question, the sum of three roots, if I'm taking the three roots to be alpha, beta, and gamma, the sum of the three roots is minus b upon a. So minus of minus 7p upon 1, that gives you 7p. Now you are given that the sum of two roots is equal to 0. That means if I'm taking alpha and beta as those two roots, alpha plus beta is equal to 0. From here, you will simply get gamma is equal to 7p. Right? Also, this was the first thing. Sum of the roots is equal to minus b upon a. Product of the sum of the roots, that's alpha beta plus beta gamma plus gamma alpha is equal to c upon a. So that is 5q upon 1. That's 5q itself. So you can have here alpha beta plus, I'll take gamma common, alpha plus beta is equal to 5q. You know this is equal to 0. You have alpha beta is equal to 5q. Let's name this as equation 2. And this is equation 1. Now, third thing, the product of the three roots is equal to minus d upon a. So d in this case is minus 6, a is 1. This will be equal to minus 6 upon 1. That's equal to minus 6. Now, this was equal to 5q. 5q is equal to minus 6, which gives you, not q, sorry. This is, yeah, q only. Okay. 6r. It was 6r. So gamma, I have to write gamma was equal to 7p. Okay, alpha and beta, that was equal to 5q and gamma was equal to 7p. This is equal to minus 6r. That gives you 5q is equal to 6r upon 7p. See, sorry, this is minus and minus. So this will be plus. Okay. 5q is equal to 6r upon 7p. This is what we needed to find out. 5q is equal to 6r upon 7b. That is option B is the correct answer. Hope you understood this. Next is question number 14. If alpha, beta are the irrational roots of this given equation and p is equal to 1, q is equal to -7, you have to find out what alpha minus beta mod is. The given equation is 3p square q cube px square qx plus 3 is equal to 0. When p is equal to 1, q is equal to -7. So let's fill in. So when p is equal to 1, square x cube plus 1 x square minus 7x plus 3 is equal to 0. So that makes 3x cube plus x square minus 7x plus 3 is equal to 0. Now on putting x is equal to 1, you have 3 into 1 cube plus 1 square minus 7 into 1 plus 3 is equal to 0. 3 plus 1 minus 7 plus 3 is equal to 0, which is true. That means x is equal to 1 is one of the answers, or x minus 1 is a factor. X is equal to 1 is a root and x minus 1 is a factor in equation 1. If I'm taking this as equation 1. So let's divide it to find out the rest equation. X minus 1. 3x cube plus x square minus 7x plus 3. So the first thing it will go with is 3x square. So this is 3x cube minus 3x square minus plus, they will cancel out, and you have 4x square minus 7x plus 3. So this becomes plus 4x square. This is 4x square plus 3x plus 7x minus 3. I'll redo the division. There is some problem. So that was equal to 3x cube plus x square minus 7x plus 3. This has to be divided with x minus 1. So first of all, it will be divided with 3x squared. You will have 3x cube minus 3x square minus plus. They will cancel out. You will have 4x square minus 7x plus 3. Next, it will be plus 4x. So this will become 4x square minus 4x minus plus. They will cancel. And you have minus 3x plus 3. So this will be minus 3 now. Minus 3x plus 3 plus minus, they will cancel and you will have 0. So that means the two factors came out to be x minus 1. So two factors are x minus 1 and 3x squared plus 4x minus 3. That means it can be written as x minus 1 into 3x squared plus 4x minus 3 is equal to 0. Right? If I solve this one, this gives me irrational roots. This will give me irrational roots. If I'm taking alpha and beta be the two roots, so that means alpha and beta, that's equal to minus b upon a. So this is equal to minus 4 upon 3. Similarly, alpha multiply beta is equal to c upon a. That is equal to minus 3 upon 3, which is equal to minus 1. And what you had to find out in the question? Mod of alpha minus beta. Okay. You know one thing, alpha minus beta can be written as alpha plus beta whole square minus 4 alpha beta, correct? Mod of it will be the root of it, right? This is root of alpha plus beta whole square minus 4 alpha beta. So that's equal to minus 4 upon 3 whole square gives me 16 by 9 minus minus plus 4. That is equal to 36. So this becomes 36 plus 16, 52 upon 9. So that's 2 root 13 upon 3. This is the value of mod of alpha minus beta 2 root 13 upon 3. This is the answer to the question. 2 root 13 upon 3. Option C. Hope you understood this. Let's move to the next question then. Question number 15, the roots of the cubic equation fx is equal to 0 are diminished by minus 3 by 2 so as to remove the term containing x squared. And the transformed equation is this much. You have to find, then the equation fx is equal to 0 is. Here you are given the transformed equation, which is x cubed minus 54x minus 78 is equal to 0. Roots of the cubic equation fx is diminished by minus 3 by 2. Right? Since we don't have the original equation, but the transformed equation, therefore we will verify it through the given options. I'll pick up the first option, that is 2x cubed minus 9x square minus 0 into x minus 6 is equal to 0. Here the x term is missing. So one thing to note, the roots are diminished by minus 3 by 2. So if this is a cubic polynomial, if I'm taking the three roots to be alpha, beta, and gamma. So the three roots, there are certain things, alpha plus beta plus gamma. You know, sum of the roots is equal to minus b upon a. That means it is equal to minus of minus 9 upon 2. That gives you 9 upon 2. This is the sum of the roots. Now, that's it. It's saying the roots are diminished by minus 3 by 2. So when roots are diminished by minus 3 by 2, that means, so if I'm taking the new equation to be some a x cubed plus b x squared plus c x plus d is equal to 0. So this will be minus of alpha minus of minus 3 by 2 plus beta minus of minus 3 by 2 plus gamma minus of minus 3 by 2 should be equal to minus b upon e. Here the x square coefficient is missing. It is given the x square term is removed. That means this is equal to 0, right? So alpha plus 3 by 2, beta plus 3 by 2, and gamma plus 3 by 2 should come out to be 0. Should come out to be 0. Now, question number 15, the roots of the cubic equation fx is equal to 0 are diminished by minus 3 by 2. Here minus 3 by 2 is representing the diminished one. So as to remove the term containing x squared, and the transformed equation is this, then the equation fx is equal to 0 is given by. So in this question, you are given two things. First is this transformed equation, and then you are given the root of the cubic equation fx is equal to 0 are diminished by minus 3 by 2. Since we don't have the original equation, but the transformed equation, therefore we will verify it through using the options. That will be the easiest way to go with. So let's pick up the first option, A. 2x cubed minus 9x square minus 6 is equal to 0. So this is a cubic polynomial. Let alpha, beta, gamma represent the three roots. So alpha plus beta plus gamma is equal to minus, this is, sum is equal to minus b upon a. So that's minus of minus 9 upon 2, which makes it 9 by 2. Now said the roots are diminished by 3 by 2. So when the roots are diminished, so the new roots will be alpha minus 3 by 2 plus, not plus, beta minus 3 by 2 and gamma minus 3 by 2. It is said that they remove the term containing h square. Actually, h square is not present here also. So they removed it in, so that means in the transformed equation, b is equal to 0. See from here also, x square coefficient is not there. That means b is equal to 0. And sum of roots is equal to minus b upon a. So that means that is equal to 0. So let's find out the sum of the roots. Alpha plus beta plus gamma minus 3 by 2 plus 3 by 2 plus 3 by 2. Right? So here in the first option, we received alpha plus beta plus gamma is equal to 9 by 2. 9 by 2 minus 9 by 2, that gives me 0. So that means we have option A as the correct one, because this is the one which gave me the correct transformation. X square coefficient is missing, x square is missing, term is missing. So option A is the correct answer to the question. Hope you understood. Next is question number 16. If MPR minus, okay, this whole term, this is actually A raised to power M minus 1 PR, not A raised to power, sorry, this is A multiply M minus 1 PS, then A minus S is equal to. So, one general formula, that is NPR is equal to N minus 1 PR plus R raised to power N minus 1 P R minus 1. Okay. Okay. So now over here, if we compare them, let's write down this one also. MPR. Question number 16. If MPR minus this whole term is equal to A multiply this, then A minus S is equal to. So you are given, let's write down MPR minus M minus 1 PR is equal to A multiply M minus 1 PS, then A minus S is equal to. Let's simplify this. You can have MPR is equal to M minus 1 PR plus A raised to power M minus 1 PS. We know that NPR is equal to N minus 1 PR plus R N minus 1 P R minus 1. So let's comparing both them. You will get, see over here, A is equal to R. Second thing, S is equal to R minus 1. We need to find difference between the two. So A minus S is equal to R minus 1. That's equal to 1. So A minus 1, S is equal to 1. Option A is the correct answer. Hope you understood. Next is question number 17. The total number of ways of selecting 4 letters of the word EAMCET is. Let's write down the word TSEAMCET. So here you can see T is occurring twice and E is also occurring twice. So that means the different letters are SAMC, TT and EE. That means we have 6 distinct letters. So you have to select 4 letters from different letters. First way is 4 letters are selected and all are distinct. So this can be done in 4 ways. That is equal to 6 factorial upon 4 into 2 factorial. This gives me 15. Right. Next, second way. 2 letters are alike and 2 letters distinct. So 2 letters alike. There are 2 pairs of alike letters. This 2C1. Multiply, I'm left with 5. So 5C2 again. So that becomes 2 into 5 factorial upon 3 factorial into 2 factorial, which is 5 into 4 upon 2 into 1. That gives you 20. Third way, two letters are alike and two are also alike. Rest two are also alike. Now this can be done in 2C two ways, that is equal to 1. So the total number of ways are 15 plus 20 plus 1, that is equal to 36. Sorry for that. I just accidentally, actually you can rewind the video to get the solution of the answer. We arrived at the solution. It was 36. So option D is the correct answer. Hope you understood this, right? You can rewind the video if you want to watch the sum again. Next is question number 18. Numerically greatest term in the expansion of this when x is equal to 1 by 3 and y is equal to 1 by 2 is. So, you know one thing. If I have this a plus b raised to power n, then tr plus 1 is given by ncr into a raised to power n into b raised to power n minus r. For the numerically greatest term, you have tr plus 1 upon tr. That's given by ncr a raised to power r, b raised to power n minus r, ncr minus 1, a raised to power r minus 1, b raised to power n minus r plus 1. That's given by ncr upon ncr minus 1 whole divided by. See this a raised to power r minus 1, a raised to power r, dividing them, you will get a over here. Similarly, denominator will be left with b. So this is equal to a upon b. Now ncr upon ncr minus 1, this is equal to n minus r plus 1 upon r into a upon b. Now you are given, see in this question, a is equal to 2x and b is equal to minus 3 by. A is equal to 2x and b is equal to minus 3y. X was given to you as 1 by 3, so a is equal to 2 by 3, and b was given to you as 1 by 2, so this is equal to minus 3 by 2. Also, in the question, you are given that n is equal to 11. So let's fill in all these things in the given question. So tr plus 1 upon tr is equal to 11 minus r plus 1 upon r. That's multiplied by 2 by 3 upon minus 3 by 2. That gives you 12 minus r upon r into 4 by 9. Now this is, of course, greater than 1. That means 48 minus 4r, let's do the cross multiplication, is greater than 9r, which gives you 13r less than 48, or this. That means r is less than 3. So tr plus 1, which was given by ncr, a raised to power r, b raised to power n minus r. That's equal to 11c3 into 2 by 3 raised to power 3 minus 3 by 2 raised to power 11 minus 3, that is 8. So this is the answer to the question. Let's check with the options. Okay, still, okay, sorry, still there is, so let's solve it. This is 11c3, 3 by 2. See, the negative sign will go away because this is a even power, and this will be 5. So 11C3, 3 by 2 raised to power 5 is option B. Hope you understood this. Let's move to the next question then. Question number 19. If x minus 2 upon x squared 2x minus 3 is equal to this expression, then 2a minus c is equal to. Basically, I have to find out a and c, so we'll solve the problem without any problem. X minus 2 upon x squared 2x minus 3 is equal to a into x squared into 2x minus 3 plus b into x into 2x minus 3 plus c into x cube. This whole is divided by x square to x minus 3. The denominators will cancel out each other and you will be left with x minus 2 is equal to a x square. Let's open it. And not, sorry, here is ax only because x was already in the denominator. So it is supposed to be ax square only, right? This is equal to ax to x minus 3 plus this b plus cx cube. Fine. So at x is equal to 0, minus 2 is equal to minus 3b. See, this will be equal to 0 and this will be equal to 0. So minus, and this is also equal to 0. So minus 2 is equal to minus 3b, which gives you b is equal to 2 by 3. Next, at x is equal to 3 by 2, you have minus 1 is equal to c into 9 by 4. See, at x is equal to minus 1 by 2, you will have this is equal to minus 3 by minus 1 by 2. And this will be equal to 0. This term will be equal to 0. This term will be equal to 0. And you will have here 3 by 2 whole cube. So you will ultimately get minus 2. Sorry, here is square, not cube. Again, a mistake. Okay, because here was square in the denominator. So that is equal to 9 by 2, 9 by 4. That gives you c is equal to minus 2 by 9. Now again at x is equal to 2. When you're putting x is equal to 2, you will get this as 0. So 0 will be equal to 2a plus b plus 4c, or a will be equal to 1 by 2 minus b minus 4c, or a will be equal to, let's fill in the value for b, that was minus 2 by 3, and 4c is equal to 8 by 9. That's equal to 1 by 2. There is no minus. That's equal to 1 by 2 minus 6 plus 8 upon this, which will be 1 by 9. Right? Now, we have all the three values. I have a is equal to 1 by 9. I have b is equal to, what is the value of b? It was 2 by 3. C is equal to 1 by 9. I have to find out 2a minus c. So 2, 1 by this minus this. That's going to give me, wait. Okay. C was equal to minus 2 by 9. Sorry. Question number 19. If x minus 2 upon x squared 2x minus 3 is equal to this whole expression, then 2a minus c is equal to what? So in this question, let's find out the LCM first thing. You will write x minus 2 upon x squared 2x minus 3. I'm taking the LCM. This will be whole divided by x squared 2x minus 3. So this will be a into x into 2x minus 3 plus b into 2x minus 3 plus c x squared. Now, denominators will cancel out each other and you will have x minus 2 is equal to x into 2x minus 3 into a plus 2x minus 3 into b plus cx square. Okay, now at x is equal to 0, if I put x is equal to 0, you will have minus 2. See, this term will be 0 and this term will be 0. So you will have 2x is equal to minus 3b, which will give you b is equal to 2 by 3. Now, at x is equal to 3 by 2, you will have minus 1 by 2 is equal to c into 9 by 4. See, at x is equal to 3 by 2, this will be 0, this will be 0, and this will be minus 1 by 2. So this will be minus 1 by 2 is equal to c into 9 by 4, which gives you c's value as minus 2 by 9. Now at x is equal to 2, the LHS will go away. So that is 0 is equal to 2a plus b plus 4c. 2a is, I don't know the value for 2a, but b is equal to 2 by 3 plus 4 into this. So 2a will be equal to 8 by 9 minus 2 by 3, which will be equal to this 2 by 9. Or a will be equal to 1 by 9. Now I got the values. A is equal to 1 by 9. B was equal to 2 by 3. And C is minus 2 by 9. You have to find out the value of 2a minus c. So 2a minus this c, that gives you 2 into 3 upon 9 or 2 by 3. So this is the value 2 by 3. I don't have 2 by 3 in the options, but I have everything in terms of b. What is the value of b? That was 2 by 3. So that means a is equal to b. Sorry, 2a minus c is equal to b. That is option D. Hope you understood this question. Next is question number 20. Similar type of question again. So this whole expression is equal to this whole expression. You have to find out the value a plus 2b plus c plus d, 2d. Again, I'll be following the same way that we have done before. X squared minus x plus 1 whole divided by x square plus 1 x square plus x plus 1 is equal to, let's take the LCM on the right hand side, x square plus 1, this. So this will be ax plus b into x square plus x plus 1 plus cx plus d x square plus 1. LHS, denominators will cancel out. So x squared minus x plus 1 is equal to ax plus b x squared plus x plus 1 plus cx plus t into x squared plus 1. So I'll open up the brackets. This will be ax cube plus ax squared plus ax bx square bx plus b cx cube cx dx square plus t, that's equal to x square minus x plus 1. So x square minus x plus 1 is equal to a plus c x cube a plus b plus t x square a plus b plus c x plus b plus d. Now comparing the corresponding coefficients. Comparing corresponding coefficients. You have a plus c is equal to 0. A plus b plus d is equal to 1. This is equal to minus 1 and b plus d is equal to 1. Okay. So these are the 4 equations. Now from equation 1 and 3. You will get b is equal to -1 from equation 4. See, it is -1 plus d is equal to 1. That gives you d is equal to 2. From equation 2, a plus -1 plus 2 is equal to 1. That gives you a is equal to 0. Now from 1, a plus c is equal to 0. A was 0, so c is also 0. What we had to find out in the question? A plus 2b plus c plus 2d. Let's write down. We got the value of a as 0, b as -1, c as 0, and d as 2. So 0 plus 2 into -1, that's -2, plus 0 plus 4, that is equal to 2. So the answer to the question is 2, which is option D. Hope you understood this. Let's move to the next question, number 21. If sine A is equal to this -7 by 25 and cos B is equal to 8 by 17, then A does not lie in the third quadrant and B does not lie in the first quadrant, then 8 tan A minus 5 cot B is equal to. Okay, you are given sine A is negative and sine A does not lie in the third quadrant, which means sine A, of course, lies in fourth quadrant because it's negative there. Similarly, you are given cos B positive, that is 8 by 27. Also, you are given that it does not lie in the first quadrant. So that means B is positive only in the first and the fourth quadrant. So B lies in fourth quadrant. Both lie in the fourth quadrant. Okay. So now, sine A was minus sine 7 upon 25. That is perpendicular upon hypotenuse. So from here, so these are the two values. According to that, 25 square minus 7 square is equal to the base square, which gives you the base as 24. So here, you'll have the base as 24. I need to find out tangent of A. Tangent of A, that's perpendicular upon base. So perpendicular upon base, that is minus of 7. This was 7. Okay. So minus of 7 upon base was 24. Minus 7 upon 24. Let's go with the cos B now. So cos B is 8 upon 17, which is base upon hypotenuse. So base is 8 and hypotenuse is 7. So 17 square minus 8 square is equal to perpendicular square, which gives you the perpendicular as 15 on solving. This gives you perpendicular as 15. What you need to find out here? Chord B. So, chord B is equal to, since it's lying in the fourth quadrant, so negative. So minus B upon P, that gives you minus 8 upon 15. We need to find out 8 tan A minus 5 cot B. So 8 into minus 7 by 24 minus 5 into minus 8 by 15. This gives you minus 7 upon 3 plus 8 upon 3, which is 1 upon 3. So the answer to the question here is 1 upon 3. That is option B. Hope you understood. Let's move to the next question then. Question number 22. If sine theta minus cos theta is equal to 1 by root 3, then sine 2 theta plus cos 4 theta plus sine 6 theta is equal to. You are given sine theta minus cos theta is this. Now, let's squaring the both sides. Let's do squaring the both sides. You will have sine square theta plus cos square theta minus 2 sine theta cos theta is equal to 1 by 3. And you know this is 1 minus sine 2 theta is equal to 1 by 3. That gives you sine 2 theta is equal to 2 by 3. Now we got one thing. Let's go with the second one, that is cos 4 theta. Cos 4 theta can be written as 1 minus sine 2 sine square 2 theta, right? And we have the value for sine 2 theta. This will be 1 minus 2 into 2 by 3 raised to power 2. That is 1 minus 8 by 3. That will 8 by 9. That will give you 1 by 9. So you got the second value as well, cos 4 theta. Let's go for sine 6 theta now. So this is sine 6 theta. I'll introduce one thing. 4 sine cube 2 theta is equal to 3 sine 2 theta minus sine 6 theta. That will give you sine 6 theta is equal to 3 sine 2 theta minus 4 sine cube 2 theta. Sine 2 theta was equal to 2 by 3. So this, that gives you 2 minus 4 into 8, that's 32 on 27. That gives you 54 minus 32 upon this, or 22 by 27. We got all the three values. You had to find out the value of sine 2 theta, cos 4 theta, sine 6 theta. That was equal to 2 by 3. This is 1 by 9 and this is 22 by 7. Let's take the LCM. So this is 18 plus 3 plus 22. That gives you 43 upon 27. So this is the answer to the question, 43 upon 27. That is option D. Hope you understood. Let's move to the next question, number 23. If A tan alpha plus B tan beta is equal to A plus B tan alpha plus beta by 2 and alpha minus beta is not equal to 2 and pi, then cos beta upon cos alpha is equal to what? So basically in the question, I have to find out what is cos beta and cos alpha equal to. Okay, let's go. So A tan alpha plus, you are given A tan alpha plus B tan beta is equal to this. So I'm opening this. You can write down this as A into tan alpha plus beta by 2 plus B tangent of alpha plus beta by 2. Now let's concatenate the A terms. You will have A tangent of alpha minus tangent of alpha by 2 is equal to B tangent of beta minus tangent of, this is alpha plus beta by 2 minus tangent of beta. Okay, so now using the formula, see, we have a formula using the formula tangent of P minus tangent of Q is equal to sine P minus Q upon cos P upon cos Q. So this above statement or equation from equation 1, this can be written as A into sine alpha minus alpha plus beta upon 2 upon cos alpha into cos alpha plus beta by 2 is equal to B sine alpha plus beta upon 2 minus beta upon cos alpha plus beta upon 2 into cos beta. Okay, so now this is A into, so 2 alpha minus alpha plus minus beta, this gives you alpha minus beta upon 2 upon cos alpha, because these two will cancel out. Okay, so this is equal to B into sine This is alpha minus beta upon 2 upon cos beta. So also these two will cancel. That means A upon cos alpha is equal to B upon cos beta. We had to find out the value of cos beta upon cos alpha. That is equal to B upon A. So this is the answer to the question, B upon A, option D. Hope you understood this question, right? Let's move to the next question, number 24. So we have an assertion and a reason problem before us. The chord hx is equal to this for k belonging to k is between 0 and 2. And the reason for the same is the graph y is equal to tan hx always lies between the lines y is equal to -1 and y is equal to 1. Okay, I'll pick up both the assertion and the reason one by one. First of all, I'll pick up the assertion. It says cot hx is equal to 1 minus k upon 1 plus k for k belonging between 0 and 2. You know what the value for cot hx? This is equal to e raised to power x plus e raised to power minus x upon e raised to power x minus e raised to power minus x. This dividing the numerator and the denominator 1 by e raised to power x. Okay, you'll have 1 plus e raised to power minus 2x, 1 minus e raised to power minus 2x. This can be written as 1 minus e raised to power minus 2x upon 1 plus e raised to power minus here. 1 plus minus e raised to power minus 2x. So if I compare it, these two equations, you will have k is equal to minus e raised to power minus 2x. You know one thing, e raised to power minus e raised to power minus 2x belongs to minus infinity and 0, which simply means k belongs to minus infinity and 0, which means this assertion is wrong. Now let's move to the words the reason. You have the graph for y is equal to tan hx. Let's plot the graph for the same. So I'm going for the reason now. The graph for this tan hx is somewhat like this. Okay, this is -1 and 1. This is x and the y-axis. So clearly here y lies between -1 and 1. That means the reason is true, which means option D is the correct answer. Hope you understood. Let's move to the next question, number 25. 5 sine h2x plus upon 7 plus 6 cos h2x is equal to 3 by 2. Then 3 tan h square x plus 20 tan hx is equal to. Let's pick up this. You have 5 sine h2x upon 7 plus 6. This is equal to 3 by 2. So I'll open up sine 2x can be written as 5 into 2 tan hx upon 1 minus tan h square x whole divided by 7 plus 6, 1 plus tan h square x, 1 minus tan h square x is equal to 3 by 2. So this will be 10 tan hx, and this will denominators will cancel. You will have 7, 1 minus tan h square x plus 6, 1 plus tan h square x is equal to 3 by 2. Okay, let's do the cross multiplication. So 20 tan h square is equal to, I'll take 3 outside, and this will be 7 minus 7 tan h square x plus 6 tan. This is 20 tan hx is equal to 13 minus this. So that makes, this is a quadratic equation now, 3 tan h square x plus 20 tan h x is equal to 39. Now, this is a quadratic equation, right? What we need to find out in the question was 3 tan h square x plus 20 tan h. Okay, so this is equal to 39. This is what we got in the answer. Option C. Hope you understood. Let's move to the next question, number 27. Sorry, 26. In a triangle ABC, A is 7, B is 8, tan C is this. And C is a acute angle, then C is equal to. Okay. First thing, you are given these three things. A, you are given B, you are given, and tangent of the angle C is given to you. I'll pick up that tangent. Tan of C is this. So, you know, the tangent is perpendicular upon base. That means this is 3 root 5 and this is 2. So the hypotenuse will be equal to the root of 9 into 5 plus 4. That is equal to 49. So hypotenuse comes out to be 7. Okay. Right. So here you have the perpendicular as this, base as 2, and hypotenuse as 7. That means cos C can be written as, that's base upon hypotenuse, so 2 upon 7. Also, you know, cos C is equal to A square plus B square minus C square upon 2AB. Now I have all the values. I just need to find out the value of C. I have the cos C, that is 2 by 7. That is equal to A square. A was equal to 7, so 49. Plus B square, that is 8 square, 64, minus C square upon 2 into 7 into 8. Okay, these 7 will cancel. And you have 16, that's 32 is equal to 113 minus C square, or C square is equal to 113 minus 32, that is 81. So C is equal to 9. That's it. You can't have a negative value for C. So C is equal to 9. Then it is option D. Understood? So let's move to the next question. But before moving to the next question, students, here's a quick reminder to visit our website, www.examsnet.com. You know very well, you will have multiple entrance exam question papers of the similar type, and this type also on our website. The PDF is available. So do explore our website to have a better exposure to all of these skills. Next, you can also download our app. The link is available in the description box. Let's go with the next question, number 27. In a triangle ABC, if A upon tan A is equal to B upon tan B is equal to C upon tan C, then you have to find out the value of this given expression. Okay. So tan A, can I write tan A like this? A into cos A upon sin A is equal to B upon cos B upon sin B is equal to C upon C into cos C upon sin C, right? Now you also know one thing. A upon sin A is equal to B upon sin B is equal to C upon sin C is equal to some 2R. Now this equation 1 becomes using second equation 1 becomes 2R cos A is equal to 2R cos B is equal to 2R cos C, which simply means cos A is equal to B is equal to cos C, which is only possible when you have each angle to be equal, that is A, B, and C. They are all equal and they all are equal to 60 degrees. This is the only possibility, right? So we had to find out the expression cos square A plus cos square B plus cos square C to find cos square A plus cos square B plus cos square C, which simply means this is equal to 3 cos square A. So cos A, that is cos 60 degree, that is 1 by 2. That makes the answer to the question as 3 by 4, which means option B is the correct answer. Hope you understood. Next is question number 28. In the triangle ABC, if A is equal to 7, B is 10, C is 11, then capital R upon small r is equal to. Okay, you know the value of R that is given by ABC upon 4 delta, or R is equal to small and small r is equal to delta upon S, which means capital upon small r is equal to ABC upon 4 delta whole divided by delta upon S, right? Which gives you ABC multiply S upon 4 delta square. Now you know semi-perimeter, that is S, is given by the sum of the sides divided by 2. You are given A as 7, B as 10, C as 11 upon 2, that is 40. Let's find out delta. That is area S into S minus A, S minus B, S minus C. So 14 into 14 minus 7, 7. 14 minus 10, 4. 14 minus 11, that is 3. So this is equal to, so delta, this was equal to delta. Delta square can be written as, we need delta square, right, over here. So I'm not taking the root now. That's 14 into 7 into 4 into 3. I will not do the multiplication because that will only increase the time for doing the calculations. There is no need of it. I'll fill everything in this equation number 1. Right? Filling all values in equation 1. You will have R capital upon small r is equal to, see the value was equal to A, B, C into S upon 4 delta square. So A was 7, B was 10, C is 11, S came out to be 14. 4 delta square is 14 into 7 into 4 into 3. So let's do the cutting and everything. 7 and 7 will cancel. 14 will go away. And this is 2 and this is 5. So you will be left with 55 upon 24. And this is you needed to find out. 55 on 24. This is option B. Hope you understood. Next is question number 29. Let ABC be the triangle and the ABC are the position vectors of ABC vertices, respectively. And D divide the line BC in the ratio 3:1 internally, and E divide AD in the ratio 4:1 internally. Let BE meet AC in F. Okay, a lot of things are given to you, so you won't be able to understand it. Let's make the figure first. There is a triangle ABC. This is it. This is the triangle ABC. Now you're given that ABC are the 3 position vectors, A, B, and C. Let D divide the line BC in the ratio 3:1. There's a point D. So this is dividing the line in the ratio 3:1 internally, and E divide the line AD in the ratio. Okay, there is this line AD, and E divides the line AD in the ratio 4:1. Like this. Internally. Let BE meets AC in F. BD meets AC. Where is AC? Yeah, sorry. Okay, let BD meets BE. So sorry for this. This was the point E. So BE meets AC in F. Let the position vector of this be F. and this has a position vector as E, and this has a position vector as D. I think we have drawn everything. Let be E meet AC in F, and E divides BF. E divides BF in the ratio 3:2 internally. Then the position vector of F is, okay. First of all, let's talk about the section formula, because to do the sum, you need to do this sum is full of section formula. You can't understand it without that. And you had done the section formula in your class 10th. That section formula is given by, if there is a line and a point divides the coordinates x, y, divides the line with the coordinates x1, y1, and x2, y2 in the ratio m1:m2, then x is given by m1 x2 plus m2 x1 upon m1 plus m2. Similarly, y is given by m1 y2 plus m2 y1 whole divided by m1 plus m2. Okay. Now we already have assumed that D has a position vector of D. F is having this position vector and E is having this position vector, right? So D can be given by, the position vector of D will be given by 3 into C plus 1 into B. See, I'm using this line BC, okay? Whole divided by 3 plus 1. This will give you 3C plus B upon 4. See, the reason was it's a divider of BC. Similarly, E is divider of AD over here. So E vector, that is divider of AD, it is given by 4 multiply D plus 1 multiply A whole divided by 4 plus 1. See, D already we have calculated from here. I'll fill this D over here. This is 4 into 3C plus B upon 4 plus A whole divided by 5. That is equal to A plus B plus 3C upon 5. Okay. Next, I'm taking BF. So from BF, E is also the divider, right? E is the divider of BF also. So E can be written as, here I'm taking E as the divider of BF. So E can be written as 3 into F plus 2 into B upon 3 plus 2. So that's equal to, see, E we just calculated, that was equal to A plus B plus 3C upon 5 is equal to 3 in F plus 2B upon 5. That gives you A minus B plus 3C is equal to F, right? Okay, sorry, 3F. A minus B plus 3C is equal to 3F. So F can be written as 1 by 3 A minus B plus 3C. That's it. We needed to find out the value of vector F, that is equal to 1 by 3 A minus B plus 3C, which is option D. See, this whole thing is in the vector form only, right? These are the vectors, this F and B. All these things, they are vectors only. Okay, so they are actually only the vectors. So hope you understood the problem. Let's move to the next question, number 30 now. If alpha, beta, gamma are real numbers such that 7 by 3 plus beta. So this whole thing, this I plus, wait, this I minus j plus k is equal to this plus beta, this plus this. Then 5 alpha minus 9 beta plus 13 gamma is equal to. Okay, let's see. You are given 7 by 3 plus beta I minus j plus alpha plus gamma k. This is equal to, wait, I minus j plus alpha plus gamma k is equal to 5 by 3 alpha I plus j minus k plus beta 2j plus k plus I plus gamma j and 3k. Okay, so let's simplify this. Dividing both the sides by 3, you will have 7 plus 3 beta I minus 3j plus 3 alpha 3 gamma k is equal to 5 alpha I plus j minus k plus beta into 6j 3k plus 3i plus 3 gamma j 9k. Okay. Okay, fine. Now I'm segregating the terms having the I cap and j cap and k cap on both the sides. So 7 plus 3 beta I cap minus 3 j cap plus 3 alpha 3 beta k cap is equal to 5 alpha plus 3 I cap plus 5 plus 6 beta 3 gamma k cap, sorry, j cap plus minus 5 plus 3 beta plus 9 k cap. So now comparing the corresponding components. That is, I am comparing with I, similarly j with j and k with k. You will have 7 plus 3 beta is equal to 5 alpha plus 3, which gives you 3 beta is equal to 5 alpha minus 4. So let's name it as number 1. Also, you have minus 3 is equal to 5 plus 6 beta plus 3 gamma. That gives you 3 gamma is equal to minus 8 minus 6 beta. So 3 gamma is equal to, you have 3 beta as 5 alpha minus 4. So this is equal to minus 2 5 alpha minus 4. 3 gamma is equal to minus 8 minus 10 alpha plus 8, or 3 gamma is minus 10 alpha. Let's name it as number 2. Now the third comparison of k component, you will have 3 alpha 3 gamma is equal to minus 5 plus 3 beta plus 9. So 3 alpha is equal to 4 plus 3 beta minus 3 gamma. This is the equation 3. On putting the values from equation 1 and 2 into equation 3. Putting 1 and 2 in equation 3, you will get 3 alpha is equal to 4 plus 5 alpha minus 4 minus of minus 10 alpha, or 3 alpha is equal to 5 alpha plus 10 alpha, which gives you alpha is equal to, wait, okay, this gives you alpha is equal to 0, because no other option is a 3 alpha can be equal to 5 alpha plus 10 alpha. That means 3 alpha can be equal to 15 alpha. And this is the only possible case when alpha is equal to 0. Otherwise, it's not possible. Now, from equation 1, 3 beta is equal to, 3 beta was equal to 5 alpha minus 4. That means 3 beta is equal to minus 4 or beta is equal to minus 4 by 3. Now from equation 2, 3 gamma is equal to 0, right? Which makes gamma also equal to 0. Now you had to find out the value of 5 alpha minus 9 beta plus 13 gamma. To find 5 alpha minus 9 beta plus 13 gamma. So this is 0 minus 9 minus into 4 minus 4 by 3 plus 0, that gives you 12. So the answer to the question is 12. That is option B. Hope you understood this. Then let's move to the next question. Question number 31. If R is equal to this I plus this J plus this K is a vector equation of the plane, then the equivalent Cartesian equation of the plane is. Okay, you're given R is equal to 2 minus lambda plus mu I plus 1 minus mu J plus 2 minus 3 lambda plus 2 mu K is a vector equation of the plane. So R can be written as 2I plus J plus 2K. So I'm segregating the lambda and the mu terms now. Plus lambda minus I minus 3K plus mu I minus J plus 2K, which is a plane through which is a plane through A vector is equal to 2I plus J plus 2K and parallel to the vectors. Therefore, B is given by this minus I cap minus 3 cap, and C vector is given by I minus J plus 2K. Therefore, it is perpendicular to the vector. It is perpendicular to the vector R minus A into N is equal to 0. So R into N is equal to A into N, right? R into question number 31. If R is equal to this I plus this J plus this K is a vector equation of the plane, then the equivalent Cartesian equation of the plane is. So R is 2 minus lambda plus mu I plus 1 minus mu J plus 2 minus 3 lambda plus 2 mu K. Here, so I'm segregating the non-lambda and the mu terms now. This will be 2I plus J plus 2K plus lambda minus I minus 3K plus mu I minus J plus 2K, which is a plane through A is equal to this 2I plus J plus 2K and parallel to the vectors. Also, B is minus I minus 3K and C is I minus J plus 2K, right? Therefore, it is perpendicular. It's given, not given actually. It is perpendicular to the vector N is equal to B multiplies C, or N is given by I, J, K minus 1 taking from here 0 minus 3, taking from here 1 minus 1 and 2. So this is equal to I cap 0 minus 3 minus j minus 2 plus 3 plus k 1 minus 0. That makes n equal to minus 3i minus j plus k. Hence, its vector equation is r minus a into n is equal to 0. That makes r into n is equal to a dot n. Actually, these are the dot products. Right. And I don't know what r is, but n is given by this. So minus 3i minus j plus k is equal to a into n. So a was this vector and n is this vector. Let's write it here. A vector was given by 2i plus j plus 2k. So this is equal to, let's do the dot product of both of them. You will have minus 6 minus 1 plus 2. Okay, so r into minus 3i minus j plus k is equal to minus 5. This was the vector equation or the Cartesian equation. See, I'm assuming the r to be some xi plus yj plus z into k dot product with the minus 3i minus j plus k is equal to minus 5. So this is minus 3x minus y plus z is equal to minus 5, which gives you 3x plus y minus z is equal to 5. Let's check with the options. You have option A as the correct answer. Hope you got that. Next is question number 32. If A is given by this vector, B is given by this vector, and x is equal to this, y is equal to this, theta be the angle between A and B such that x squared plus y squared is equal to what? Okay, so here you have A vector as 2i plus j minus k and B vector as I minus j plus 3k, right? X will be given by A dot B upon, it's given actually in the question, magnitude of B square multiply by B. So this is equal to, let's do the dot product of both of them. You will have 2 minus 1 minus 3 upon magnitude of B square will give you B square it is. So this is equal to 1 plus 1 minus 1 square is 1 plus 3 square is equal to 9. That gives you into B was there. That gives you minus 2 by 11 and B was equal to I minus j plus 3k. This is for x. Now let's go with the y. The given y is equal to a dot b multiplied by divided by the magnitude of a square whole multiplied by this, and a dot b is same 2 minus 1 minus 3 upon a's magnitude, that is 2 square plus 1 square plus 1 square. So 2 square is 4 plus 1 into a, that gives you this is equal to minus 2 upon 6 into a, or this is minus 1 by 3. A was equal to 2i plus j minus k. Right. Now you have to find out x squared plus y squared. Let's do that. X squared will be equal to 4 upon 1 to 1 I minus j plus 3k dot I minus j plus 3k plus 1 by 9 2i plus j minus k 2i plus j minus k, the dot product of them. So this is 121 multiply 1 minus minus plus 1 and 3 3s are 9 plus 1 by 9, 2 2s are 4, 1 1 the 1, minus 1 into minus 1, again 1. So this is 4 upon 124 into 11 plus this. So you have 4 upon 11 plus 2 by 3. That gives you 12 plus 22 upon 33, which is 34 upon 33. Right. So 34 upon 33 is the answer, but that's not present in the options. But I have all the terms of cos theta over here. So let's go with that. Maybe it will help to find our option. So, cos theta is given by this, right? So the dot product of them, that's equal to 2 minus 1 minus 3. And this magnitude of A was given to you as 6, root of 6. And this is root of 11. Okay. B's magnitude, see over from above. A dot B was equal to 2 minus 1 minus 3. Magnitude of A was equal to root of 6 and magnitude of B is root of 11. So that is root of 6 into root of 11 mod. So this is this, right? Now this can be written as minus will come outside, root 2 upon root of 3 into 33. That is, yes, that is equal to root of 33. Now, because this is a modulus sign, so this will be equal to root of 2 upon 33. That was equal to your cos theta. Let's do the squaring on both sides. So cos theta, cos square theta is equal to 2 upon 33. Okay. But I need to have this 34 upon 33. So you have 7 multiplying both sides by 17. So 17 into this, right? That is equal to 34 upon 33. So 17 cos square theta is equal to x squared plus y squared. This is the answer to the question. So 17 cos square theta is the answer to the question, option A. Hope you got that. Next is question number 33. Let pi1 be the plane passing through the point this and perpendicular to this vector. Let the line L passing through this and this be a normal to the plane pi2. If the angle between the planes pi1 and pi2 is theta, then cos theta is equal to. Okay, so first thing, equation of the plane passing through these points. Equation of the plane passing through the points 3i minus 2j plus k and I minus I plus 3j plus k is r is equal to 3i minus 2j plus k plus the lambda difference between the two. So 3 minus of minus 1 will be 4i. Minus 2 minus 3 will be minus 5j and k's will go away. So plus 0. Okay. Now vector perpendicular to the plane 1. Vector perpendicular to plane pi1 is given by minus j plus 2k. Also vector perpendicular to plane pi2 is this 4i minus 5j. We know the angle between the two planes is same as the angle between the vector perpendicular to them. We know angle between two planes is same as angle between vectors perpendicular to them. So let angle theta Let that be angle theta. Therefore, cos theta is given by minus j plus 2k dot 4i minus 5j divided by their magnitudes. So that is equal to, it will be 5. Yeah. This will be 0 because I is missing. And minus 1 minus 5, that is going to give you plus 5 plus 2 into 0 whole divided by, this is 1 plus 4, that is equal to root of 5, and 16 plus 25, that is equal to 41, that is root of 41. So that gives you 5 upon root of 5 into 41. This can be written as root of 5 upon root of 41, that is equal to root of 5 upon 41. So this is the answer to the question, option A. Hope you got that. Next is question number 34. Three non-coplanar vectors ABC are continuous edges of the parallelepiped AB. If AB determine the base of this, then its height is. So you are given that A and B determine the height of parallelepiped A and B determine height of parallelepiped. We know volume of it is given by magnitude of this, and volume is given by area of the base multiplied by height. Area of the base is magnitude of this. You had to find out the height. Height is given by ABC magnitude upon this. So this is given by option B. This is the answer to the question. Hope you understood this. Let's move to the next question, number 35. Question number 35. Statement 1 says the range of the ungrouped data does not change even if certain intermediate observations are removed. Okay. In the question, we have 3 statements. You have to find out which are true and which are false. We'll read the statements and discuss them side by side. First statement says the range of the ungrouped data does not change even if certain intermediate observations are removed. Well, the range depends on the minimum and the maximum value. So it will not be affected by the intermediate observations, that for sure. That means statement 1 is correct. Statement 2, the value of mean deviation of an ungrouped data about the median is always less than or equal to the value of the mean deviation computed about any other measure of the central tendency. Well, it is true that the mean deviation of an ungrouped data about the median is always less than or equal to the value of the mean deviation computed about any other measure of the central tendency. This is absolutely true as well. Statement 3, for a grouped data, range is approximated as the difference between lower limit of the largest class and the upper limit of the smallest class. See, for the group data, range is approximated as the difference between lowest value, highest, and the lowest value. So this statement 3 is wrong. That means we have statement 1 and 2 are true, but statement 3 is false. Option A is the correct answer. Hope you understood. Next is question number 36. The probability of getting a king and a spade when two cards are drawn simultaneously from a pack of 52 cards is. Question number 36. Question number 36. The probability of getting a king and a spade card when two cards are drawn simultaneously from a pack of 52 playing cards is. So in this question, you are having two cases. First case, when you are withdrawing a spade king plus a spade card. So there is only one spade king, and if I'm withdrawing one spade king, how many spade cards I'm left with? 12. So this is 12 ways this can be done. Second case, when we are withdrawing non-spade king and a spade card. Now, how many non-spade kings are there? 3. And how many spade cards are there? 13. So this is equal to 39. Now you have to find out the probability of getting a king and a spade card when two cards are withdrawn simultaneously from a pack of 52 cards. Therefore, the required probability is given by 39 plus 12 upon 52 C2 because we have to withdraw two cards. So this is equal to 51 upon 52 factorial into 50 factorial into 2 factorial. This is equal to 51 factorial into 2 upon 52 into 2, into 51 factorial. So you have 1 upon 26 as the required answer. Let's check with the options. That means option A is the correct answer. Hope you got that. Next is question number 37. Two cards are drawn from a pack of 52 playing cards, one after the other. If P1 is the probability of getting a queen in the first draw and a diamond in the second draw, when the first card is drawn is replaced, and P2 is the probability of the same event when the first card drawn is not replaced, then P1 upon P2 is equal to. So you are having P1 as the probability of the first card drawn is queen and second card drawn is diamond. So how many queens are there? There are 4 queens out of 52 cards. Multiply diamond cards are 13. So 13 by 52, that gives you 1 by 52. Okay, now P2. P2 is the probability case, when the first card is drawn, and P2 is the probability of the same event when the first card drawn is not replaced. Okay, so in P2, I'm having two cases. First case, when the queen is not diamond. When the queen is not diamond, so that means there are 3 queens now out of 52 multiplied by 13 out of 52. Second case, when the queen is diamond. When the queen is diamond, that means 1 queen. Of course, only 1 diamond queen is there. 1 by 52 multiplied by, now I have taken out 1 diamond queen. So how many diamond cards I'm left with? 12. This. That gives you, I'll leave it as such only. Sorry, 51. Because I have taken 1 card from here. And sorry, this is also 51. Yeah. Okay. So now this is the probability P2. So P2 probability will be given by 3 upon 52 into 13 upon 51 plus 1 upon 52 into 12 upon 51. Right? I hope you got this thing because 51, because we have already taken out a card in this case. Now this is equal to 39 upon 52 into 51 plus 12 upon 52 into 51. That gives you 51 upon 52 into 51, which is equal to 1 upon 52. So we have to find out the probability P1 upon P2. To find was P1 upon P2. P1 we calculated, it was 1 by 52, and P2 also came out to be 1 by 52. So the answer to the question is 1. That means we have option A as the correct answer. Hope you got that. Next is question number 38. Let E1, it says the bag A contains 4 white and 2 black balls. Bag B contains 3 white and 3 black balls. Bag C contains 2 white and 4 black balls. If a bag is chosen at random. Question number 38. Bag A contains 4 white and 2 black balls. Bag B contains 3 white and 3 black balls. Bag C contains 2 white and 4 black balls. Okay, let's make the bags first. So this is bag A. This bag contains 4 white, 2 black balls. Bag B contains 3 white, 3 black balls. And bag C contains 2 white and 4 black balls. If the bag is chosen at random and a ball is chosen at random from it, then the probability that the ball chosen is black. So basically, I'm having 4 probabilities which we are talking about in the question. Let events, sorry, not the probabilities, events. Let E1 be the event that ball is drawn from bag A. E2 and E3 be the event that ball is drawn from bag B and C, respectively. Now let E be the event that ball drawn is black. E is event that ball drawn is black. Correct? So if this is the event, probability of event 1 to happen, that is a ball is drawn from bag A, is equal to probability that the ball is drawn from bag B is equal to the probability that the ball is drawn from bag 3, and this whole is equal to 1 by 3. 3 bags, 1 bag will be chosen, so the probability is equal to 1 by 3. Now, probability of withdrawing a black ball from bag A, that is equal to 2 by 6. Similarly, probability of withdrawing a black ball from the bag B is equal to 3 by 6. That is 1 by 2. Now the probability of withdrawing a black ball from the bag C is given by 4 upon 6. That is equal to 2 by 3. Okay. Now you have to find out the probability of event E to happen, that is withdrawing a black ball. This is given by probability of event E1 into this plus E3 this. Now you have all the values, just multiply. This is 1 upon 3 into 1 upon 3. 2 by 6 this is. Plus 1 by 3 into 1 by 2. 1 by 3 into 2 by 3. So this gives me 2 by 18, 1 upon 6, 2 upon 9. I have the LCM as 18. That gives me 2 plus 3 plus 4. That is 1 by 2. So this is the required probability, 1 by 2. Option C is the correct answer. Hope you understood this. Next is question number 39. A random variable x has a probability distribution given by like this, where k is a real number. That the number 1, it has a probability 10k, 2 has the probability 9k, 3 has this, 4, and so on. Now, if A is xi such that xi is a prime number and B event is that xi such that xi is greater than 5, these are the two events, then the probability of A union B is. First thing, you know that the summation of the probability, the total probability is always equal to 1. That means 10k plus 9k plus 8k, 9k plus 8k plus 8k plus 6k plus 5k plus 4k plus 3k plus k is equal to 1. So adding them, you will get 54k is equal to 1, or k is equal to 1 upon 54. Now A says the A is xi such that xi is a prime number. So what are the elements of A? It's 2, 3, 5, and 7. And what are the elements of B? B is greater than 5. So 6, 7, 8, and 9. Okay. So probability of A is given by 2 is 9k plus 8k plus 6k plus 4k. 9 plus 8 plus 6 plus 4. That gives you 27k. Yeah. So, you know, k is equal to 1 by 54. So that's 1 by 2. Okay. Now the probability of B. For 6, you have 5k, 4k, 3k, and k. 5k, 4k, 3k plus k. That is equal to 13k, or 13 into 1 upon 54. That is equal to 1 upon, it will remain as such. I'll leave 13 upon 54 only. Okay. So now you have to find out A union B. Let's go. You know the formula for that, but let's find first of all A intersection B. What is A intersection B? That is only 7, because 7 is the only number which is a prime as well as greater than 5. So probability of A intersection B is actually the probability of number 7, and that is 4k. 4k, that is equal to 4 into 1 upon 54, that is 1 by 27. Now you have to find out the probability of A union B, that is equal to probability A plus B minus PA intersection P. PAB was equal to, A was equal to 1 by 2. See, everything has the denominator as 54, so I will keep this as 27 by 54 for the easier calculations. So that is 27 by 54, and PB was equal to 4 by 54. Sorry, this is not 1 by 27. Okay, this is 2 by 27 actually. So 4 upon 54. Sorry, PB is equal to 13 by 54. And that is equal to 4 upon 54. 54, 27 plus 13 minus 4. This gives you 40 minus 4, 36 upon 54, or 2 by 3. So this is answer to the question 2 by 3, option A. Hope you got that. Let's move to the next question, number 40 then. If X is a Poisson variate such that 5 upon 3k is equal to probability X is equal to 2 is equal to P, X is equal to 3, then you have to find out Px is equal to 5. Okay, you have a general formula. Px is equal to X is given by lambda raised to power X, e raised to power minus lambda upon X factorial. So if I'm taking this one, you are given Px is equal to 2 is equal to Px is equal to 3. So That's given by lambda raised to power 2 e raised to power minus lambda whole divided by 2 factorial is equal to lambda cube e raised to power minus lambda upon 3 factorial. So first thing you will have cancel. Okay, let's solve it properly. So you have 3 factorial upon 2 factorial is equal to lambda cube into e raised to power minus lambda upon lambda square into e raised to power minus lambda. They will cancel out and you will have, this will be 3 is equal to lambda. That's it. Because lambda square will go up and this will be lambda. This, that is equal to lambda. That means you get the value of lambda as 3. Now you have to find out x is probability, x is equal to 5. That is given by lambda raised to power 5 into e raised to power minus 5 upon 5 factorial. Let's break it up. You can write it as x cube, lambda cube, lambda square, e raised to power minus lambda. Sorry, here is not 5, here is lambda. Upon 5 factorial. So I can write it here as minus lambda upon 2 factorial into 2 factorial upon 5 factorial, right? So lambda was equal to 3. That means 3 cube. This is equal to 5 by 3k. We are given here in the question. This was equal to px is equal to 2, right? And this was equal to 5 upon 3k. It was given to you in the question. So multiplied by 2 upon 5 into 4 into 3 into 2 into 1. Okay, so this 3 and this 3 will cancel out. You will have a, 1 over here. So this is equal to 3 into 5 into k. Okay, 5 I left to cancel out. So that is equal to 3 by 4k. This is the answer to the question, 3 by 4k. It is option D. Hope you got that. Let's move to the next question, number 41. Question number 41. A and B are two fixed points. C and D are 2 points on y-axis such that CD is equal to 4. C is below D. Okay, let's we'll find out like what we have to do. What we have to find out. We'll talk about that later. First of all, let's make the figure for this. This is the coordinate axis because you are given the coordinates. So I'll make the coordinate axis. Here's the coordinate axis. A and B are this. So this is point B. Let's make a straight line. So this is the point B, which is having the coordinates as 4, 0, and point A is having the coordinates as minus 4, 0. Okay. So now here given C and D are 2 points on y-axis such that CD is equal to 4 and D is below, C is below D. So here is if I'm taking C, that means here is D. Also, you are given that this is 4. Let the coordinates of C be 0, h, then the coordinates of D will be 0, h plus 4. So this is the system, like this is the situation. We have to find out the locus of the point of intersection of the lines AC and BD. Okay, if this is produced and this is produced, you have to find out the locus of the point of intersection. Okay, so first of all, I'll pick up the line AC. Let's talk about it. So if I talk about AC, you can find out equation of AC in slope-intercept form. That is given by y is equal to, the general equation is y is equal to mx plus b. So y, what is m over here? I'm talking about AC. C is having the coordinates as 0h. A is having minus 4, 0. So the slope is given by h minus 0 upon 0 plus 4 x, and b is the y coordinate, that is h over here. That makes it y is equal to h by 4x plus 1. I'll take h common. So that is x by 4 plus 1. That makes y upon h is equal to this, or y upon h minus x upon 4 is equal to 1. Okay. From here, if I find out the value of h only, this is first of all in the slope-intercept form, the equation of AC. Slope-intercept form, sorry. Right. From here, you can see h is equal to 4y upon x plus 4. Okay. And now I'll take the line BD. Similarly, the equation of BD will be given by, in the slope-intercept form, it will be given by, you will solve it. You will have B is having the coordinates 4, 0, and D is having B 4, 0, and D is this. Right? So this is given by y is equal to h plus 4 minus 0 upon 0 minus this, x plus h plus 4. So solving this, you will get x by 4 plus y upon h plus 4 is equal to 1, or 4 minus x upon 4 is equal to y upon h plus 4. That gives you h plus 4 is equal to 4y upon 4 minus x, or h is equal to 4y upon 4 minus x upon minus 4. This is equation 2 and this is equation 1. Both are the values of h. So equating 1 and 2, you will get 4y upon x plus 4 is equal to 4y upon 4 minus x minus 4. So let's do the cross multiplication. You will have 4y into 4 minus x is equal to 4y into 4y into x plus 4. Wait, I'll bring this 4y upon x plus 4 minus 4y upon 4 minus x is equal to minus 4. I'll take 4y common. So 1 upon x plus 4 minus 1 upon 4 minus x is equal to minus 4. They will cancel out, not y, 4. So you will have y into 4 minus x minus 4 upon 16 minus x square is equal to minus 1, which will give you, you will have these two cancellations over here. Minus 2xy is equal to minus 1 into this, or 2xy is equal to 16 minus x square, or x square plus 2xy minus 16 is equal to 0. This is the locus of the given point of intersection. So we have option B as the answer. Hope you got that. Let's move to the next question, number 42 then. By rotating the axis through an angle of 30-degree anti-clockwise direction about the origin, the equation this becomes this. Then, okay, you are given that this is the original equation, 4x square plus 12xy plus 9y square plus 6x plus 9y plus 2 is equal to 0. Now the x is being rotated 30-degree anti-clockwise direction. Axes are rotating 30-degree anti-clockwise. So that means x will be equal to the capital X. X will be transformed to this. 30-degree. Cos 30 is root 3 by 2 x. Sine 30 is 1 by 2 y. So this will be equal to root 3x minus y upon 2. Now for y, it will be similarly for y, it will be x sine 30 plus y cos 30 degree whole divided by 2. That is equal to by rotating the axis to an angle of 30 degree in the anti-clockwise direction about the origin. This equation becomes this. Then which of the following options is correct? So you are given that this is the line 4x square plus 12xy plus 9y square plus 6x plus 9y plus 2 is equal to 0. Now, since the axis is rotating at an angle of 30 degree in anti-clockwise direction, so the coordinates will be shifted to x will become x cos 30 degree. I'll write it like this. X is equal to x cos 30 degree minus y sine 30 degree, and y will be transformed to x sine 30 plus y cos 30. Cos 30 degree is root 3 by 2 and this is 1 by 2. That makes it root 3x minus y upon 2. And here y is equal to x into 1 by 2 y into root 3 by 2, which makes it root 3y plus x upon 2. Now the required equation will become it was 4x square. I'll pick up the whole equation. Okay, now. So you have to be very carefully examining everything. 4x square. So this is equal to root 3x minus y upon 2 square plus 12 root 3x minus y upon 2 into x plus root 3y upon 2 plus 9x plus root 3y upon 2 square plus 6 into root 3x minus y upon 2 plus 9 into x plus root 3y upon 2 plus 2 is equal to 0. So now let's open it up. First thing, this 4 and 2 square, this will cancel. And here will be 3. So here nothing will happen here. Here will be 3 and that's it. So you will have here, let's open it. So 3x square plus y square minus 2 root 3x y plus 3 root 3 x square plus 9 xy minus 3 xy minus 3 root 3 y square plus 9 by 4 x square plus 27 by 4 y square plus 9 root 3 upon 2 xy plus 3 root 3x minus 3y plus 9x by 2 plus 9 root 3 by 2y plus 2 is equal to 0. So now let's combine the like terms. You will get 12x square plus 4y square minus 8 root 3xy plus 12 root 3x square 36xy, 12xy minus, I'll write minus over here. Okay. Minus 12 root 3x y square. 12 root 3 y square plus 9x square plus 27y square, 18 root 3xy plus 12 root 3x minus 12y plus 18x plus 18 root 3y plus 8 is equal to 0. Okay, I'll I'll segregate the x square, xy, y square terms now. So you will get x square 21 plus 12 root 3, y square 31 minus 12 root 3, xy 10 root 3 plus 36 plus x 12 root 3 plus 18 plus y 18 root 3 minus 12 plus 8 is equal to 0. So here you have a as this 21 plus 12 root 3 and b is this 31 minus 12 root 3. So here if you see what is h. H is half the coefficient of xy, half the coefficient of xy, which gives it 5 root 3 plus 18. What is g? It is half the coefficient of x, which makes it 6 root 3 upon plus 9. And f is half the coefficient of y, which is 9 root 3 minus 6. Right, we have all the values now. A, B, H, G, F. I think we have all the values. What we need to do in the question was, okay, A is equal to 21 minus 6 root 3. That's wrong. A is equal to something else. Okay, so option A is incorrect. Let's go with the second one. G upon F is equal to this. Let's solve that. G upon F. So from here, G upon F will be given by 6 root 3 plus 9 upon 9 root 3 minus 6. So I'll divide the numerator and the denominator by 3. You have 2 root 3 plus 3, 3 root 3 minus 2. That's it. We got our answer. This is option B. 2 root 3 plus 3 upon 3 root 3 minus 2. That's it. We got the option B as the answer. There is no point of solving further options because we already don't have much of the time. Okay. Hope you understood this question, students. Let's move to the next question, number 43. Before solving this question, students, it's a quick reminder to visit our website, www.examsnet.com, to explore the site and practice many more entrance exam question papers of similar type. You can also download our app. The link is available in the description box. So here we go with the question number 43. In an isosceles triangle, the ends of the base are this and this. Let's make the figure. So you are given isosceles triangle is there. That means two sides are equal. The base is, the two ends of the base is this. Let's make. So if it is, this point is 2a comma 0 and 0 comma a, let's say this is over here. Okay, so this is the base. Let's say there is a third point, x1, y1. Third vertex is given x1 and y1. Okay, I'm naming this as A. So you are given that if I'm taking the point B and I'm taking this as the point C, so you are given that AB is equal to AC. Okay, all right. So isosceles triangle, these are the two coordinates and one of the other sides is a horizontal line of other than the x-axis. Okay, And the third vertex is this. That means AB is a horizontal line. Sorry, it's not, AB is not the horizontal line. At one of the other sides is a horizontal line other than x-axis. AB is not the horizontal line. We don't know which one is the horizontal line. But one thing is for sure, if one another side is horizontal line, then question number 43, in an isosceles triangle, the end of the base are this and this. And one of its other two sides is a vertical line other than y-axis. If the third vertex is given by x1, y1, then x1 plus y1 is equal to. So basically in the question, you have to find out these values separately and then we will add them. Simple as that. Let's make the figure first. So you are given the coordinates. It will be very helpful if you draw them on the coordinate plane. Okay, this is somewhere here. And the two coordinates are, here is 2, 2a, 0. And the second one is 0, a. So somewhere, let it be here. Okay. I'll draw it a bit down. So let it be here. Okay. Now, you are given the third vertex is at x1, y1. Also, one more thing. And one of, this is the base, first thing. You are given this is the base. And other two sides, one of the other two sides is a vertical line. So that means this will be a vertical line, right? This is the vertical line. And this is the third vertex. Let it be x1, y1. And I'm naming this as C and B. So this is A, this is B, and this is C, the 3 points. This is an isosceles triangle. That means this BC is the base, which means AC is equal to AB, and these are the coordinates. Next, you are given that AB is a vertical line. If AB is a vertical line, that means x1 is equal to 2a. Very important point to note in the question. Now, I'll get back to AC is equal to AB. Also, you can write down AC square is equal to AB square. We have the coordinates. I'll apply the distance formula. AC square can be written as x1 minus 0 square plus y1 minus a square. AB will be written as x1 minus 2a square plus y1 minus 0 square. x1 was equal to 2a, so this thing will be 0. You can write it as x1 square plus y1 square plus a square minus 2a y1 is equal to 0 plus y1 square. So this will be it, right? Now, these two will cancel out. And you will have x1 was equal to 2a, so 2a square will be equal to 4a square plus a square minus 2a y1 is equal to 0. 5a square minus 2a y1 is equal to 0, or y1 will be equal to 5a upon 2, right? And we already know that x1 is equal to 2a. You just have to add the two values. So 5a upon 2 plus 2a upon 1, that will give you 9a upon 2. So this is the answer to the question. Option A is the correct answer. Hope you understood this. Next is question number 44. There are three lines, L1, L2, and L3. These are the three equations. They are congruent, and theta is the acute angle between L1 and L3. Then tangent of theta is equal to. So these are the three lines, L1, L2, and 3. You are given that three lines are congruent. If these three lines are congruent, then the determinant, if I solve, that is equal to 0. That means 1 minus 1 minus 2, 3. So these are the coefficients 2, 1, 1, 3, 1, 1, 3, 1, C. So determinant is equal to 0. Let's find out the determinant. That is 1 into C minus 1 plus 2 to C minus 3 plus 3 2 minus 3 is equal to 0. Solving it further, you will have c minus 1 plus 4c minus 6 minus 3 is equal to 0, or 5c minus 10 is equal to 0, which will give you c is equal to 2. You got the value of c? So that means we are talking about L1 and L3. We have to find out theta is the acute angle between them, tangent of theta. So that means now I'm concerned only for the lines L1 and L3. What is L1 equal to? X minus 2y plus 3 is equal to 0. From here, you can write down y as 1 by 2x plus 3 by 2. If I'm talking about L3 is written as 3x plus y plus 2 is equal to 0, which will give you the value of y as minus 3x minus 2. That's it. So from here, L1, let's write down for L1 and L3. For L1, y was equal to 1 by 2x plus 3 by 2, and L3, y was equal to minus 3x minus c, or minus 2. Here slope is 1 by 2, and here the slope is minus 3. Now you have to find out that theta is the angle between both of them. Tangent of theta is given by m1 minus m3 upon 1 plus m1 into m3, product of the slopes. So that's 1 by 2 minus minus plus 1 by 3, 1 plus 1 by 2 into minus 3 modulus. That will give you 7 by 2 upon 1 minus 3 by 2, which will give you minus 1 by 2. So minus 7. Actually, it's mod, sorry. So this is all under the mod. That means 7 is the answer. Right. Tangent of theta is equal to this. 7 is not there in the options. Okay, c plus something is there. C was equal to 2, right? So that means 2 plus 5. Option C is the correct answer. Right? Hope you understood this. C, we got the answer as 7. So 7 can be written as C plus 5. Option C starts to be the correct answer. Next is question number 45. If the length of the perpendiculars drawn from the point A, comma B to these two lines are same, then the point A, comma B lies on which line? Okay, so you are given that there is a point AB and these are two lines. 2x plus 3y plus 4 is equal to 0 and 3x minus 2y plus 4 is equal to 0. These two distances, they are equal. AB is equidistant from these two lines. So if AB is equidistant, the distance, let it be L1 and L2. That means L1 and L2, they are equal. L1 can be written as, see, 2 into A plus 3 into B plus 4. 2A plus 3B plus 4 upon the root of 2 square plus 3 square, which is 4 plus 9. That is equal to 3A minus 2B plus 4 upon the same thing, the root of this. These two things will cancel out. And you will have 2A plus 3B plus 4. I'm removing the modulus sign. This will be equal to plus minus 3A minus 2B plus 4. Now for the positive sign and for the negative sign. Let's go. So first case is 2A plus 3B plus 4 is equal to 3A minus 2B plus 4. Also 2A plus 3B plus 4 is equal to minus 3A plus 2B minus 4. Let's solve it. You will have minus A plus 5B is equal to 0, or A plus A minus 5B is equal to 0. Transforming it into the, see, A and B are the particular points. So in the general equation, this will be written as x minus 5y is equal to 0. Let's solve this one. You will have 5A plus B is equal to 0, or this will give you 5x plus y. Sorry, not 0. This is equal to minus 8. 5x plus y plus 8 will be equal to 0, right? These are the two lines. Let's check with the options. You have option C as the correct answer. X minus 5y is equal to 0 and 5x plus y plus 8 is equal to 0. Hope you understood this. Next is question number 46. If this, and this, there are three given lines, then this point is, number one, orthocenter of the triangle formed by the lines. This is going to take a long time if I go with this option. The point of congruence of the lines, the circumcenter of the triangle formed by the lines in center of the triangle formed by the lines. Okay, you have this point and the three lines, the equations are 3x plus 6y plus 2 is equal to 0. X plus y plus 1 is equal to 0. 2x minus y plus 3 is equal to 0. So first of all, I'll go with the easiest one, the point of congruence. So this point, I fill in this equation 3 into minus 4 by 3 plus 6 into 1 by 3 plus 2. That gives me minus 4 plus 2 plus 2, which is 0. So that means this point is lying on the first line, first equation. The second one, the point was minus 4 comma 3 upon 3, 1 upon 3. So minus 4 upon 3 plus 1 upon 3 plus 1 upon 1. 3 minus 4 plus 1 plus 3, it's going to give me 0 again. That means this point lies on the second line as well. Third one, 2 minus 4 upon 3 minus 1 upon 3 plus 3. That gives me minus 8 upon 3 minus 1 upon 3 plus 3 upon 1. 3 minus 8 minus 1 plus 9. This will be 0 upon 3. Or simply 0. That means this point lies in the third line as well. That means simply this is the point of congruence of the three lines. Option B, the easiest one, is the correct answer. Hope you understood this. Next is question number 47. If theta is the acute angle between these pair of lines, then tangent of theta is equal to 8 by 19. You have to find out the value of h. Let's talk about it. You have the general equation ax squared plus 2hxy plus by squared is equal to 0. Here the tangent theta is given by the formula 2 root of h square minus ab upon a plus b. So here a is 12 in this question and h I don't know, I have to find out. B is 7. Let's find out, and you're given tangent of theta is 8 by 19. So 8 upon 19 is equal to 2 root of h square minus 12 into 7 upon 12 plus 7. That will be 2 root of this minus 84 upon 19. That's equal to 8 upon 19. These two will cancel and this will cancel with 4. So 4 is equal to root of h square minus 84, which will give you h square minus 84 is equal to 16, or h square is equal to 100, which makes h value as plus minus 10. That's it. We got the answer. Plus minus 10 is option D. Hope you got that. Next is question number 48. The number of real values of alpha for which the pair of lines represented by this are at right angle to each other is. Now you're given that the lines are at right angle. If the lines are at, see, this represent A and the coefficient of y represents B. You are given that the lines, they are at right, that means they are perpendicular to each other. For perpendicular lines, you have the coefficient of a square, that x squared, that is a, and the coefficient of y squared, that is b, the sum of them to be equal to 0. Let's write it down. You have alpha square plus 12 into mod of alpha plus 18 minus 21 mod of alpha is equal to 0, which gives you alpha square plus 12 this minus 21 mod of alpha plus 18 is equal to 0. Alpha square minus 9 alpha plus 18 is equal to 0. Now you have a quadratic equation. Let's solve. The two factors will be splitting the middle term. You have 6 alpha minus 3 alpha plus 18 is equal to 0. Alpha into alpha minus 6. I'll take this common from here. Okay. See, this is square, so I can write it like this also. No problem. Okay, mod of alpha I'm taking. So here will be this minus 6 minus 3 minus 6 is equal to 0. So the two factors are mod of alpha minus 6 and mod of alpha minus 3 is equal to 0, which gives you this is equal to 6 or that's equal to 3, which gives you alpha is equal to plus minus 6 or plus minus 3. These are the two values possible. Let's check over here what we need to find out. The number of real values of alpha. Okay, how many values are there? 1, 2, 1, 2. That means 4 values are there. Option D. Hope you understood this question. Next is question number 49. The line x plus 2y is equal to 0 meets this curve at 2 points P and Q. An angle POQ is pi by 2, where O is the origin. Okay. So the given line is this is equal to C, which makes x plus 2y upon C is equal to 1. And the given curve is x squared plus y squared minus 3x minus 6y plus 3 is equal to 0. Now by homogenization, you can write it as x squared plus y squared minus 3x into x plus 2y upon C minus 6y x plus 2y upon C plus 3 into x plus 2y upon C whole square is equal to 0. Now let's take the LCM. C square into x square plus C square into y square minus 3c x plus 2y minus 6 cy x plus 2y plus 3 x plus 2y whole square is equal to 0. Now let's open it up. You will have c square x square c square y square minus 3c x square minus 6c xy minus 6c xy minus 12c y square plus 3x square plus 12 y square plus 12xy is equal to 0. So I'll segregate the x square, y square and xy coefficient terms. You will have x square into c square minus 3c plus 3 plus y square c square minus 12c plus 12 plus xy minus 12c plus 12 is equal to 0. Now in the question, you are given that POQ angle is pi by 2. That means they are perpendicular. POQ, these are the 2 points P and Q. So POQ is 90 degree. Right, this is 90 degree. Since they are at 90 degree, that means the coefficient of x square plus the coefficient of y square is equal to 0. Since angle POQ is 90 degree or pi by 2, therefore A plus B, which is the coefficient of x square plus the coefficient of y square is equal to 0. C square minus 3c plus 3 plus c square minus 12c plus 12 is equal to 0, which makes 2c square minus 15c plus 15 is equal to 0. That's it. 2 square c square minus 15c plus 15 is equal to 0. You have to find out 2c square minus 15c. That is equal to minus 15. So we have option B as the answer. Hope you got that. Next is question number 15. The line 4x plus 3y minus 4 is equal to 0 divides the circumference of the circle in this ratio. If this is the center of the circle, then equation of the circle is, let's draw it. This is the circle, center 5, 3. The line this divides the circumference in the ratio 1 is to 2. So there is a line 4x plus 3y is equal to 4. This is the line. Now circumference is divided in the ratio 1 is to 2 ratio. Therefore, if I'm taking this as A, this as B, and this is at the center C, so angle ACB will be given by 360 upon 1 plus 2, that is equal to 120 degrees. So ACB is 120 degree. If I take this as the midpoint, D, so what will be angle DCB? That is half of 120 or 60 degree, right? This is 60 degree and you know this is 90 degree. Angle CDB is equal to 90 degree and angle DCB is equal to 60 degree. In triangle PCD, cos 60 degree is equal to P upon R. Right? What is R? It is the radius of the circle. And P is this side. CD. CD is actually P. Right? Okay. So cos 60 degree, you know, this is 1 by 2. This is equal to P upon R. R is equal to 2P. That's it. And here I need to have the value of P. I don't know. But okay, let's go for finding out the value of P. I know the equation of this line. I know the C. C falls, let's say, C falls perpendicularly on AB. Therefore, CD is equal to P. It will be given by mod of 4 multiplied by 5. See, 4x plus 3y minus 4 is equal to 0 and the coordinates were 5, 3. So 4 multiplied by 5 plus 3 multiplied by 3 minus 4. Whole divided by root of 4 square, which is 16, plus 3 square, which is 20, plus 9 minus 4, 16 plus 9, that is root of 25, which is 25 upon 5, or that's equal to 5. That's it. We have the value of P as 5. Let's pick up this. R is equal to 2P. So R is equal to 10. Right? We got the center as this and radius as 10. Let's frame the equation now. This will be x minus 5 square, y minus 3 square is equal to 10 square. That's 100. Now let's check you have option A as the answer. Hope you got that. Next is question number 51. It says two sides of a square are along the lines x is equal to minus 5 and y is equal to 4. The point of intersection of the diagonals is this, and the point of intersection of the tangents drawn to the circumference of the square at the two consecutive vertices lying on the line x is equal to 5 is. Okay, let's try and make the figure first for the problem. This is a square which is framed by x is equal to minus 5 and y is equal to 4. Question number 51. Two sides of a square are along the line x is equal to -5 and y is equal to 4. The point of intersection of the diagonals is this. Let's make the figure by the side to have a clear understanding of the problem. So here is the square. You are given the two sides are like this is equal to x. This line is x is equal to -5 and this line is equal to is y is equal to 4. These are the two lines. Let's write it here. Right now, the point of intersection of the diagonals is 3, -4. That means this and this. So this point, if I'm naming this as O, this is given by 3, -4. Right? Let it be A, B, C, and here's D. All right. So next you are given that fine. So looking at this is x is equal to -5 and y is equal to 4. Looking at that, the coordinates of D are -5 and 4. Now, O is the midpoint on BD. First of all, D has coordinates as -5, 4, and O is midpoint on BD. So let the B has the coordinates A, B. Therefore, 3, according to this question, 3 is equal to -5 plus A upon 2. Also, -4 is equal to 4 plus B upon 2. That gives you 6 plus 5, 11. That's A. And B comes out to be -8 and -4. That's -12. So the coordinates of B are 11, -12. Okay, next. You know one thing, AB is parallel to CD. Therefore, you can have the equation of AB as y is equal to -12. Now the coordinates of A will be equal to -5, -12. So A is having the coordinates as -5, -12. Now the equation of the circle, which is circumscribing it. This is the circle which is circumscribing. This is a bit, wait. So this is the circle like this, just touching the vertices here. And this is like this. Okay, now equation of this circle will be given as, see, this will be the O will be the center. Equation of circle with O as center and OD as radius. Right? This will be given by x minus 3 whole square y plus 4 whole square is equal to radius square. Radius is OD and you know the coordinates for O and D. O had the coordinates as 3, -4 and D had the coordinates as -5, 4. So OD square is equal to -5 minus 3 whole square plus 4 whole square. That gives you x minus 3 square y plus 4 square is equal to 8 square, that's 64 plus 8 square 64, that gives you 128. Correct? Let's open it. So you will have x square plus y square minus 6x plus 8y minus 103 is equal to 0. I have opened the squares. Now tangent, it's said in the question next is the point of intersection of the tangents drawn to the circumcircle of the circle at two consecutive vertices lying on x is equal to 5. What are the two consecutive vertices which are lying on x is equal to -5? Those are C and D. So that means a tangent is drawn from at C and D. So let's pick up the first one. Tangent at D, that is -5, 4 is given by -5x plus 4y minus 3 x minus 5 plus 4y plus 4 minus 103 is equal to 0. That makes minus 5x plus 4y minus 3x plus 15 plus 4y plus 16 minus 103 is equal to 0 minus 8x plus 8y minus 72 is equal to 0. That gives x minus y plus 9 is equal to 0. Now the tangent at point C. That has the coordinates as minus 5, comma minus 12. Sorry, this is A, not C. So tangent at point A, that is minus 5, comma minus 12. That is minus 5x minus 12y minus 3x minus 5 plus 4y minus 12 minus 103 is equal to 0. That makes minus 5x minus 12y minus 3x plus 15 plus 4y minus 48 minus 103 is equal to 0. That on solving gives you minus 8x minus 8y minus 136 is equal to 0, or x plus y plus 17 is equal to 0. Let it be equation 2. So now we have two variables and two equations, 1 and 2, solving 1 and 2 simultaneously. So you had the first one, x plus y plus 17 is equal to 0, and the second one was x minus y plus 9 is equal to 0. Let's add them. You will have 2x plus 26 is equal to 0, which gives you x is equal to minus 13. Now let's find out y. X minus y plus 9 is equal to 0. So minus 13 minus y plus 9 is equal to 0. That gives you y is equal to minus 4. Okay, so the required point is minus 13 minus 4. That is what you needed to find out, the point of intersection of the tangents when the tangent is drawn at D and A. The point of intersection came out to be minus 13 minus 4. That is option B. Option B is the correct answer to the question. Hope you understood this. Let's move to the next question, number 52. Before moving to the question, students, is a quick reminder to visit our website, www.examsnet.com. There you will find not only this, but a variety of similar type of question papers for your practice. The PDFs are also available. You can also download our app. You have the link in the description box. So here we go with the question number 52. L1, L2, L3 are chords of contact of 3 points respectively with respect to this circle. Then L1, L2, L3 are congruent lines, sides of a right angle triangle, sides of an equilateral triangle, or the parallel lines. Now the given equation of the circle is x squared plus y squared is equal to 3. Chord of contact of tangents drawn from chord of contact of tangents drawn from L1, L2, L3 are 2x is equal to 3, x minus 2y is equal to 3, and 4x plus 4y is equal to 3 using these 3 points, right? See here the y coordinate is 0, so 2x is equal to 3. Here x minus 2y is equal to 3 and 4x plus 4y is equal to 3. These are the 3 equations of the chord of contacts. Now for congruent lines, say delta is equal to 2, 0, minus 3, right? Looking at this one. Then the second one, 1, minus 2, minus 3. Third one, 4. 4 and minus 3 is equal to 0. The determinant is equal to 0. So let's find out. 2, 6 plus 12 minus 3, 4 plus 8. Okay. That is 2 into 18, that's 36 minus 36. That comes out to be 0. So it comes out to be 0. That means these three are the congruent lines. That's it. Option A is the correct answer. So I've picked up the option A to solve, and the first one matches. So there's no point of solving the further B, C, D sides. I'll just finish it up over here. Option A is the correct answer. Next is question number 53. Combined equation of the direct common tangents of these circles is. Okay, first one, you have the circle x squared plus y squared. You have two circles, right? Let's go with circle 1 and circle 2. Here you have x squared plus y squared plus 2x is equal to 0, and the second x squared plus y squared minus 2y minus 3 is equal to 0. So here, center minus g minus f. G's have the coefficient of x, that is -1, and f is missing, y is, there is no y. And radius is given by, I hope you know the formulas. Center minus g minus f, and radius is given by root of g squared plus f squared minus c squared. So using that formula, you have the radius as 1 square plus 0 plus 0, that is equal to 1. Here the center is minus g minus f, g is 0. So f is minus half the coefficient of y, that is -1. Minus of -1 gives you 1. Radius is root of g squared, that is 0, plus f squared minus of -3 squared. So that becomes, here is minus c. So this is equal to 3. Plus 3 it becomes, that is root of 4, or this is equal to 2. Sorry, here was C. So you have two things. We have the center and the radius for the first circle, and center and the radius for the second circle. Both are there, C1, C2. Now let's try and make the figure for this. So this is the first circle. This is having the center as -1, 0, and the radius as 1. And the other one, this is having radius as 2. So that means this is a bigger circle, and it is having the center at 0, 1. So this is like the 0, 1 over here. Right. So this circle will have look something like this. Right. This is the center of the circle, that is 0, 1, C2, and this is C1. Right. Let's combine these two, C1, C2. C1, C2 is given by root of -1 plus 0 squared plus 0 minus 1 squared, that is equal to root 2. Also, R1 plus R2 is equal to 1 plus 2, that is equal to 3. So that means you have C1, C2 less than R1 plus R2. The circles are intersecting like this. Okay. Also one thing, let here be the point A, and let here be the point B. So this is 2 and this is 1. There is an external point P. The combined equation of the direct common tangents to these two circles. So this is the point P from where I will draw the tangents at these 2 points. So it is touching the circles at these 2 points. All right, let it be touching the circles at here also. This is at point N and M and N respectively. Now, AC1 is equal to 1 unit and BC2 is equal to 2 units. Now, let's look at the triangle PAC1. Let's combine these also. So, triangle PAC1 is similar to triangle PBC2. If these two triangles are similar, then the sides, they are in the common ratio. Their ratios are similar. So PA upon PB is equal to AC1 upon BC2, which is equal to 1 upon 2. That means, see, look over here. That means simply C1 is midpoint. this C1 point is the midpoint on the line PC2. Is midpoint on PC2. Okay. Next, now let P has the coordinates as H, comma K. Now C is the midpoint. C1 is having the coordinates as this. P is having the coordinates as this. And C2 is having the coordinates as 0, comma 1. Now, C1 is the midpoint. That means -1 is equal to H plus 0 upon 2, or H will be equal to -2. Similarly, K plus 1 upon 2 is equal to 0, which gives you K's value as -1. Okay. Now, that means the coordinates of P will be -2, comma -1. Now, equation of the line which passes through this point. Equation of the line which passes through -2, -1 is given by y minus of -1 plus 1 is equal to m into x plus 2. That gives you mx minus y plus 2m minus 1 is equal to 0. Now, you know one thing, PB is perpendicular to BC2. You know this thing. PB is perpendicular to BC2. Tangent of a circle is always perpendicular to the radius of the circle. So that means if they are perpendicular, that means m into 0 minus 1 plus 2m minus 1 whole divided by m squared plus 1 is equal to plus minus 2, right? Okay, so this will be 2m minus 2 upon root of m squared plus 1 is equal to plus minus 2. I'll take 2 common from here. So this will be -1, m minus 1 upon m squared plus 1 is equal to plus minus 1, because the 2's will cancel on the numerator in both the sides. Let's do the cross multiplication. So m minus 1 is equal to plus minus this. Now let's square the both sides. You have m squared plus 1 minus 2m is equal to m squared plus 1. So here you have m is equal to 0. I hope you are clear till here. Therefore, the equation of PA will be y is equal to -1. Now, slope C1, C2, that is m1 is equal to 1. You know that's equal to tan theta. 1 minus 0 upon 1 plus 1 into 0 is equal to 1. That means theta is equal to 45 degree. You know, tangent of theta is 1 at 45 degree. Therefore, angle APM becomes 90 degree. Now, let M2 be the slope of line PM. So, the equation of PM will be y plus 1 is equal to 1 upon 0, this, which gives you 0 is this, or x is equal to -2. Now, the combined equation of the tangent, therefore, combined equation of the common tangent is y plus 1 into x plus 2 is equal to 0, which gives you xy plus 2y plus x plus 2 is equal to 0. So this is answer to the question. Let's check with the options. That is option A is the answer. Hope you understood this. Let's move to the next question, number 54 then. If HK is the center of the circle which passes through origin and gets these two circles orthogonally, then K minus 2H is equal to. Okay, so first thing is you are given that HK is the center of the circle. Let's frame the Equation of the circle with center as HK. Equation of circle with HK as the center is x minus h whole square, y minus k whole square is equal to the radius square. This will open up x square plus h square minus 2 hx y square plus k square plus 2 minus 2, sorry, ky is equal to r square. That makes x square plus y square minus 2 hx or xh minus 2 ky plus h square plus k square minus r square is equal to 0. So now let's put this is constant, right? X square plus y square minus 2 hx minus 2 ky plus the constant c is equal to 0. So now it is given that it passes through the origin. That means c is equal to 0. Since circle passes through origin, therefore c is equal to 0. That makes the equation as x square plus y square minus 2 hx minus 2 ky is equal to 0. Now it is given that this is orthogonal to these two circles, right? Here is a small change in the question. Actually, this is 2. There is 2x instead of this 4x. Let's write it down. Now, this is orthogonal to x square plus y square plus, let's write it over here, x square plus y square plus 2x plus 6y plus 12 is equal to 0, and x square plus y square plus 4x minus 6y plus 9 is equal to 0. So this makes minus 2h minus 6k is equal to 12, and this makes minus 4h plus 6k is equal to 9. So let this be equation 3, 4. Let this one be 1. Let it be 2 and 3. Okay, so adding 2 and 3, you will get minus 6h is equal to 21, which gives you h is equal to minus 21 upon 6 or minus 7 upon 2. Now, this is the value for h. Let's put this h to get the value of k. Put h is equal to minus 7 by 2 into, you will have minus 4h plus 6k is equal to 9. So that is going to give you 14 plus 6k is equal to 9, or 6k is equal to minus 5k is equal to minus 5 by 6. We got the value of h and k. K came out to be minus 5 by 6 and h was minus 7 by 2. You had to find out in the question k minus 2h. That was to find. So minus 5 upon 6 minus 2 into minus 7 by 2 minus 5 by 6 plus 7. That makes it, I'll take the 6 LCM, this 42, 37 upon 6. So this is answer to the question 37 upon 6, but this is not in the options. That means there is option none of the above. The answer to the question is 37 by 6. Let's move to the next question, number 55. Question number 54. If HK is the center of the circle which passes through origin and cuts this circle and this circle orthogonally, then K minus 2H is equal to. So you are given this is the center of the circle. Let's frame an equation for that circle. Equation of circle with HK as the center is given by x minus h square, y minus k square is equal to the radius square. So open it up, x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square is equal to 0. Let's put this as some constant. You will have x square plus y square minus 2hx minus 2ky plus c is equal to 0. This is a constant. Now it's given that this circle passes through origin. Since this circle passes through origin, therefore c is equal to 0, which makes the equation as x squared plus y squared minus 2hx minus 2ky is equal to 0. Right, now it's given that this circle orthogonally and cuts these two circles orthogonally. Now, this circle cuts two circles orthogonally. And what are the equation of those two circles? First is x square plus y square plus 4x plus 6y plus 12 is equal to 0, and x square plus y square plus 4x minus 6y plus 9 is equal to 0. So that makes from here minus 4h minus 6k is equal to 12, and here becomes 4h minus 4h plus 6k is equal to 9. Right, so solving both of these two equations simultaneously. You have two variables and two equations. So adding one and them, adding both of them, you will have minus 8h is equal to 21, which gives you h is equal to minus 21 upon 8. Now let's pick up any one equation. 4h minus 6k is equal to 12. Minus 4 into minus 21 upon 8 minus 6k is equal to 12, which makes 21 by 2 minus 6k is equal to 12, or 6k is equal to 12 minus 21 by 2. That makes 24 minus 21 by 2, or 3 by 2. That is equal to 6k, or 6k is equal to, k is equal to 1 by 4. Okay, now you have to find the value of k minus 2h. K was 1 by 4 minus of minus 21 upon 8, which makes it 1 by 4 plus 21 by 4. See, here was minus this, so the answer is minus, and this is minus as well. So this will be 20 upon 4, that is 5. So you have option D as the correct answer. Hope you understood this. Let's move to the next question. Question number 55. If minus 1 is the radical center of these three circles, then G minus F is equal to. So let this be S1 circle, S2, and S3 circle. Now for radical center, we have S1 is equal to S2 is equal to S3, which means S1 minus S2 is equal to 0. S1 minus S2, let's go for this. So S1 is x square plus y square plus 2gx minus 4y plus 4 minus x square minus y square minus 6x minus 2fy minus 12 is equal to 0. So these are the few things which will cancel down, and you will have 2g minus 6 x minus 4 plus 2fy minus 8 is equal to 0. Now, since minus 1 is the radical center, since this is the radical center. So this equation becomes 2g minus 6 into minus 1, 4 plus 2f minus 1 minus 8 is equal to 0, which makes it minus 2g plus 6 plus 4 plus 2f minus 8 is equal to 0, or 2 minus 2g plus 2f plus 2 is equal to 0, or minus g plus f plus 1 is equal to 0, which makes g minus f is equal to 1. That's what we needed to find, g minus f, that is equal to 1. Option C is the correct answer. Hope you got that. Let's move to the next question, number 56. Now, the equation of the given curve is this. You have to match the following. I'll pick up the equation and then I'll find out locus, vertex, and everything which is given over here. Let's go. So the given curve in this question is x square minus 4x plus 4y minus 8 is equal to 0. I can write it like x square minus 4x is equal to minus 4y plus 8, or x square minus 4x, adding 4 on both the sides, right? This becomes x minus 2 square is equal to minus 4y plus 12, or x minus 2 square is equal to minus 4y minus 3. Let x minus 2 is some capital X and y minus 3 is equal to some capital Y. That makes the equation as x square is equal to minus 4 into y. Now, let's name this as equation 1 and 2. The first one being this one, and the second be this one. Second. Comparing equation 2 with x square is equal to minus 4ay. You get 4a is equal to 4. That gives you a is equal to 1. Now, vertex of equation 2 is this, which means x minus 2 is equal to 0 and y minus 3 is equal to 0. That gives you x2 and y3. So vertex of equation 1 becomes 2, 3, right? Now focus of equation 2, x is equal to 0 and y is equal to minus a. X minus 2 is equal to 0, which gives you x2. And see, this is equal to y minus 3. That is equal to a. A was 1, so minus of minus 1. No, 1, sorry. That becomes y is equal to 2. Right, that means focus is 2, 2. Now, one end of the latest rectum, we got the focus and we got the vertex. Let's match that first. So focus came out to be 2, 2. This is option A. And vertex is 2, 3. That is option B. Now let's move to the one end of the latest rectum. One end of the latest rectum of equation 2 is given by x is equal to plus minus 2a and y is equal to minus a. That means x minus 2 is equal to plus minus 2a and y is equal to minus 1. And sorry, this is equal to small y minus 3. That gives you y is equal to 2. And if x minus 2 is equal to a is equal to 1, so this is equal to 2, or x minus 2 may be equal to minus 2. That gives you x is equal to 4 or x is equal to 0. Here I have y is equal to 2. Now, one end of the latest rectum of equation 1 is 4, 2 or 0, 2. That's it. So next is equation of directrix. Point of intersection of the axis and directrix. Okay, let's see 4, comma 2 and 0, comma 2. I have 4, comma 2. That means this matches with C. Correct. Now point of intersection of the axis and directrix. For that, let's frame the equation for the directrix. Equation of directrix of equation 2. That is y is equal to a, which makes y minus 3 is equal to 1, or y is equal to 2. Now the equation of the directrix. Sorry, axis, equation of axis of equation 2 is x is equal to 0, x minus 2 is equal to 0, or x is equal to 2. Sorry, this is 4. Okay. So the point of intersection of the axis and directrix is 2, comma 4. Let's match. That is, this is for D. So therefore, let's match with the options now. This is A is with 5. A is with 5, so that means B and this option are incorrect. And B is with 3. Okay, both of them. Then C is with 1. That makes option D to be the correct answer. Hope you understood this. Let's move to the next question, number 57 then. If one end of the focal chord of this parabola where a is greater than 0 is 1, comma 4, then the length of its focal chord is. Okay, you have the equation y square is equal to 8 upon a x. Here a is greater than 0. Let's make the equation of the parabola, graph for the parabola. So here you are having, this is the focus. All right, that's it. One end of the focal chord of this parabola is at 1, comma 4. So this is 1, comma 4. Let it be point A. And let this be point B, which is given by A T2 square, comma 2 A T2. Right? So y square is equal to 8 upon a. This can be written as 4 into 2 upon a into x. One end of focal chord is 1, comma 4. So that means if I put in this one, I'll get the value of a. That makes y square is equal to 8 upon ax, which makes it 4 square. 16 is equal to 8 upon a into 1. That makes a is equal to 1 by 2. Right? Now let's solve it further. You have the value of a. That makes the equation as y square is equal to 8 upon 1 by 2 into x, which makes it 16x. Now on comparing, y square is equal to 16x to y square is equal to 4ax. We have 4a is equal to 16, or a will be equal to 4. Now at the point 1, comma 4, 2a t1 is equal to y. So 2 into 4 into t1 is equal to 4, which makes t1 as 1 by 2. We have to find the length of the local focal chord. Length of the focal chord is given by a t1 plus t whole square. A was equal to 4, t is 1 by 2, and 1 upon 1 by 2 will give you 2 square. That's equal to 4 into 5 by 2 square. This will cancel and you will have 25 as the answer. So option D is the correct answer. Hope you got that. Next is question number 58. If M is the length of the latest fractum and N is the length of the major axis, of this ellipse, then the ordered pair m comma n is equal to. Now the given equation of the ellipse is 25x square 16y square minus 150x 64y. This is equal to 0. Let's write it. 25x square minus 150x plus 2 to 5. I'll add 2 to 5 on the right hand side also. Plus 16 square minus 64y plus 64. I'll add 64 on both the sides, and I'll take 1 and 11 also on the RHS. So that's it. This is for 5x minus 15 whole square plus 4y minus 8 whole square. This is equal to 400. Okay, yes. I'll take 5 outside. So 25 x minus 3 square plus 4 square is 16. Y minus 2 square is equal to 400. X minus 3 square 400 upon 25 plus y minus 2 whole square upon this is equal to 1. That makes x minus 3 whole square upon 16, y minus 2 whole square upon 25 is equal to 1. So let's put x minus 3 is equal to x, y minus 2 is equal to y. You have x square upon 4 square plus y square upon 5 square is equal to 1. Now let's compare this with x square upon b square, y square upon a square is equal to 1. You have a square is equal to 25 or 5 square, which gives you a is equal to 2. Okay, I'll just write down a square is equal to 25 and b square is equal to 16. Length of latest rectum, that is m, is equal to 2b square upon a, that is a is 5. A square is 25, a is 5. So that is 32 by 5. Now length of the major axis is equal to, which is h, that is equal to 2a, so 10. You had to find out m. Sorry, this is n. So m comma n is equal to 32 by 5 comma 10. That is answer to the question. Option B is the correct answer. Hope you understood. Next is question number 59. If P, theta and Q, theta pi by 2 plus theta are 2 points on this ellipse and locus of the midpoint of PQ is given by this, then alpha A plus B upon alpha plus beta is equal to. Now your given equation of the ellipse is this. Here the coordinate of P is here. Coordinates of P is A cos theta, B sin theta, and Q has the coordinates as A cos pi by 2 theta and B sin pi by 2 plus theta. This can be written as minus A sin theta and B cos theta, right? See, okay, fine. Let HK be the midpoint on PQ. This is the point P, this is the point Q. Q is given by minus A sin theta, comma B cos theta, and P is given by A cos theta, B sine theta, and this is the point R with the coordinates h, k, right? H is given by, see, this is the midpoint, right? So 1:1 ratio is there. H is equal to A cos theta K is equal to B sine theta B cos theta upon 2, which gives you 2H upon A is cos theta minus sine theta, and 2K upon B is B sine theta B. Sorry, B I have taken already. Plus cos theta. Right? Let's do the squaring the both sides. You have 4h square upon a square is equal to cos square theta plus sine square theta is equal to 1. 1 minus 2 sine theta cos theta. Here 4k square upon b square is equal to 1 plus 2 sine theta cos theta. Let's add both of them. You have 4h square upon a square, 4k square upon b square is equal to 2. That makes h square upon b square plus k square upon, h square upon a square plus k square upon b square is equal to 1/2. Now, therefore, locus of midpoint of PQ is, see, this is x square upon, looking at this one, this is given by x square upon a square plus y square upon b square is equal to 1/2. Let's do the cross multiplication. 2x square upon a square plus 2y square upon b square is equal to 1, which makes a square, x square upon a square by 2, y square upon b square by 2 is equal to 1. Right? Now you are given, but that is equivalent to x square upon alpha square, y square upon beta square is equal to 1. So that means alpha square is equal to a square by 2 and beta square is equal to b square by 2, which makes alpha is equal to a by root 2 and beta is b by root 2. Now you have to find out the value of a plus b upon alpha plus beta. So I'll keep it as a plus b upon a by root 2 plus b by root 2, which makes it a plus b upon a plus b, this, that is root 2. So the answer to the question is root 2, option D. Hope you got that sum. Next is question number 60. Let S be the focus of this hyperbola lying on the positive x-axis. Let P minus 1, 1 be the given point. Then the area of the triangle formed by the line PS with the coordinate axis in square units. Okay. First thing, you are given the equation of the hyperbola x square minus 2y square is equal to 1. This can be written as x square upon 1, y square upon 1 upon root 2 square is equal to 1. On comparing this with x square upon a square minus y square upon b square is equal to 1, you get a square is equal to 1 and b square is equal to 1 by root 2 square, which makes a as 1 and b as 1 by root 2. Right? Now, e is given by root of 1 plus b square upon a square. That is root of 1 plus b square is 1 by 2. So 1 by 2 upon 1. That makes it root of 3 by 2. That is e. Focus is AE comma 0. Right? A was 1. So 1 into root 3 by 2. It's root 3 by 2 comma 0. Now the equation of the line PS y minus 0 is equal to, the slope is given by, see the coordinates, let's write down the coordinates once. Here the P is having the coordinates, it's given, it's -1, 1, and S we just found out it's √3/2, 0. So the slope is given by 0, 0 -1 upon √3/2 plus 1. X minus √3/2, right? Let's understand it by making the figure. It will be better for you to understand. Let's make it. Here is the equation, and if I'm taking this as S, this is having coordinates as √3/2, 0. And here is the point P -1, 1. This is the point of intersection of this line with the axis. And this is the curve x square minus 2y square is equal to 1. Okay. So I hope you understood till here. Solving it further, you get y is equal to -1. I'll take √2 up. So √3 plus √2 x minus √3/2. That is y is equal to minus this into x plus √3 upon 2. Now the coordinate of A, where the x is equal to 0. So the equation becomes y is equal to √3 this. That is equal to AO. This. So the coordinates are 0, √3 upon √3 plus √2. These are the coordinates for point A. You have to find out the area AOS, that is given by half into OA into OS. OA we just calculated, it is this. And OS is given by this, right? You know, OS is the x coordinate. It's given by √3/2. Okay, so now let's write it in a proper way. √3 upon √2 plus √3 multiply √3 upon √2. So you will have it here as 3 upon 2 √2 √2 plus √3. That is 3 upon 4 plus 2 √6. Right, that's the answer to the question. 3 upon, see, this is a similar one. Option C. So option C is the correct answer. Hope you got that. Next is question number 61. If P pi by 6 is the point on the hyperbola x square upon a square minus y square upon b square is equal to 1, S and S1 are its foci, S dash actually it is. And SP plus S dash P is equal to this into this, then E's value is. Okay, so you are given over here that SP plus S dash P is equal to 2SP minus SP dash. That can be written as now E x1 minus A, E x1 plus A is equal to 2 into 2A. Now solve it further. You have, sorry, here is plus in the between. So you have 2EX1 is equal to 4A, which gives you EX1 is equal to 2A. So A can be written as A secant pi by 6, that is 2A. E into 2 upon √3 is equal to 2, which gives you E's value as √3. That's it. You got the value, root 3, option C. Hope you got that. Next is question number 62. Let A, B, C, and D are the 4 points in the space. G1 be the centroid of the triangle ABC. G2 is the centroid of the tetrahedron ABCD. If P divides G1, G2 in the ratio 4:3 internally, then you have to find out the coordinates of P. You are given, this is 1, 2, 3, and 4. Let's write down. So A is -1, sorry, not -1. B 2, 0, -1. C 0, -2, 3. And D is -1, 2, and -3. Now G1 is centroid of triangle ABC. So G1 is given by 1 plus 2 plus 0 upon 3, 2 plus 0 minus 2 upon 3, 0 minus 1 plus 3 upon 3. So G has the coordinates as 1, 0, 2, 3. Now G2, this is the centroid of the tetrahedron. ABCD. G2 will be given by 1 plus 2 plus 0 minus 1 upon 4, 2 plus 0 minus 2 plus 2 upon 4, 0 minus 1 plus 3 minus 3 upon 4. 1 by 2, 1 by 2, minus 1 by 4. Right. Now it is said that G1 and G2, P divides G1, G2 in the ratio 4:3. So here is G1 with the coordinates 1, 0, 2, 3. G2 is having the coordinates as 1 by 2, 1 by 2, minus 1 by 4. So this is P. It is dividing the line in the ratio 4:3. Let the coordinates of P be X, Y, Z. Apply the section formula. Now is this sum. You have X is equal to 4 into 1 by 2 plus 3 into 1 whole divided by 4 plus 1, 4 plus 3. Y is given by, I'll write it, okay, fine. Wait. So X, Y, and Z, that is P. Now this is given by 4 into 1 by 2 plus 3 into 0 upon 4 plus 3. Then 4 into minus 1 by 4 plus 3 into 2 by 3 upon 4 plus 3. This is 5 upon 7. This is again 5 upon 7. Sorry, this is 2 by 7, 0. And minus 1 plus 2, that's 1 upon 7. So this is what we are looking for. We have to find out the coordinates of P. That is 5 by 7, 2 by 7, 1 by 7. Option A is the correct answer. Hope you got that. Let's move to the next question, number 63. If the direction ratios of the two lines are connected by the relations this, and theta is the angle between these two lines, then cos theta is equal to, you are given A minus B plus C is equal to 0. That gives you B is equal to A plus C. And A square minus B square plus 2C square is equal to 0. Right? These are the two things which are given to you. So B is equal to A plus B, A plus C. That makes A plus C whole square plus 2C square is equal to 0, which makes A square minus C square minus 2AC plus 2C square is equal to 0. You have C square minus 2AC is equal to 0. which makes C either 0 or C is equal to 2a. Now, when C is equal to 0, then see from here, when C is equal to 0, B becomes equal to A. And when C is equal to 2A, then B becomes equal to 3A. Right? Now, I hope you got this thing. Okay, theta is the angle between them. Now, A is equal to A, B is equal to A, and C is equal to A. In the second case, A is equal to A, B is equal to 3A, and C is equal to 2A, which here it makes A upon A is equal to B upon A is equal to C upon 0. And this makes A upon A is equal to B upon 3A is equal to C upon 2A. Let's name this as equation 1 and equation 2. Now, direction ratios of equation 2 are direction ratios of equation 1 are 1, 1, 0. And the direction ratios of equation 2 are 1, 3, 2. Therefore, cos of theta, it's given by 1 into 1 plus 1 into 3 plus 0 into 2 whole divided by root of 1 square plus 1 square plus 0 multiply root of 1 square plus 3 square plus 2 square whole mod, that is 4 upon root 2 root 9 plus 4, 13 and 14. So that's it, right? That makes, see here you will have 4 upon 2 root 7. That makes 2 upon root 7. That's the answer to the question. Let's check. 2 upon root 7 is option A. So this option A is the correct answer to the question. Hope you got this. Next is question number 64. If L, M, N are direction cosines of the normal to the plane passing through this, then L plus M plus N is equal to. Now, okay. Let the 3 points, first thing, let the given 3 points be. This is A, B, and C. I'm naming that as A, B, C. So the equation of the plane passing through these 3 points is x minus x1, x2 minus x1, x3 minus x1, y minus y1, y2 minus y1, y3 minus y1, z minus z1, z2 minus z1, z3 minus z1 whole mod is equal to 0. So let's fill in the value. X minus 0, 3 minus 0, 4 minus 0, y minus 1, 0 minus 1, 5 minus 1, z minus 2, 2 minus 2, 0 minus 2 is equal to 0. That makes x 3, 4, y minus 1, 4, z minus 2, 0 minus 2 is equal to 0. Let's expand it along this z minus 2. This is z minus 2 into 3 into 4 minus 4 into minus 1 plus, sorry, minus 0 plus of minus 2 x into minus 1 minus 3 y minus 1 is equal to 0, which makes it z minus 2, 12 plus 4 minus 2 minus x minus 3y plus 3 is equal to 0, which makes it 16z minus 32 plus 2x plus 6y minus 6 is equal to 0, or 2x plus 6y plus 16z is equal to 38, or x plus 3y plus 8z is equal to 19. Right? That means x plus 3y plus 8z upon root of 1 square plus 3 square is 9 plus 8 square is 64 is equal to 19 upon the same 1 plus 9 plus 64. That is that will give you 1 upon root 74 x plus 3 upon root 74 y plus 8 upon root 74 z is equal to 19 upon root of 74. Now comparing this to Lx plus my plus nz is equal to p. We have L is equal to 1 upon 74, m is equal to 3 upon root of 74, and n is equal to 8 upon root of 74. You had to find out this, this, and this. So this is equal to same thing. Actually, you have to add all of them. Adding all of them, you have L plus M plus N is, here was 3 and here was 8. 1 plus 3 plus 8 upon root of 74, that is 12 upon root of 74. So that's it. We got the answer 12 upon root of 74, which is option D. Hope you got that. Let's move to the next question. Question number 65, limit x approaching 0, x cube minus x squared minus x minus 2 upon 2x cube minus 3x squared minus 3x plus 2 is equal to 0. So if you put down the limits, you have 2 cube minus 2 square minus 2 whole divided by 2 into 2 cube minus 3 into 2 square minus 3, 2 plus 2. This is of 0 upon 0 form, which is not allowed. So we have to find out the factors from the numerator and the denominator. You easily see that x minus 2, since it is when I'm putting 2, it's coming out to be, the result is coming out to be 0. So that means x minus 2 is a factor of the numerator and the denominator as well. Okay, let's divide the numerator and the denominator with x minus 2. So this is x cube minus x square minus x minus 2, and also the denominator 2x cube minus 3x square minus 3x plus 2. So here you have x square will be this. Okay, so this will become x cube minus 2x square minus plus. They will cancel and you will have x square minus x minus 2 plus x square minus 2x minus plus. So you will have x minus 2, that means plus 2 over here, x minus 2, and this is remainder comes out to be 0. So next is here you have 2x square, so 2x cube minus 4 x square minus plus. You have x square minus 3x plus 2. Now plus x, this is x square minus 2x minus plus. You have minus x and wait, okay, minus x plus 2. You'll have a minus 1 over here, minus x plus 2. So plus minus, that means the remainder is equal to 0. So now the numerator and the denominator, this whole expression which was given to you can be written as limit x approaching 2, x minus 2 into x square plus x plus 1, x minus 2, x square, 2x square plus x minus 1. They will cancel and limit x approaching 0. This. So that makes 2 square plus 2 minus 1 upon 2 into 2 square plus 2 minus 1. That is 4 plus 1 upon 8 plus 1. That is 9. Okay, so sorry, here was plus 1, not minus 1. So you will have a 3 over here. That makes it 7 by 9. So 7 by 9 is the correct answer. Option D is the correct answer. Hope you understood this. Let's move to the next question, number 66. Question number 66, limit x approaching 0. These are the two terms which are given to you. You have to find out the solution. So this is C. This will be again 0 upon 0 form. So we have to solve it. Now this can be written as limit x approaching 0, 4. Now I'll segregate the numerator. I'll write it as sine 20, 22 x minus sine 20, 20x whole divided by x multiplied by 1 upon cos 20, 22x to cos 20, 21x plus cos 20, 20x. Okay, so let's split that further. Limit x approaching 0, 4. I will write it like sine 20, 22x upon x minus sine 20, 20 x upon x whole multiplied by 1 upon cos 20, 22x plus 2 cos 20, 21x plus cos 20, 20x. So that makes limit x approaching 0, 4 into 20, 20. I'm multiplying the numerator and the denominator with 20, 22. So this is 20, 22 sine 20, 22x upon 20, 22x minus 20, 20 into sine 20, 20x upon 20, 20x whole multiplied by 1 upon cos 20, 22x plus 2 cos 20, 21x plus cos 20, 20x. Cos, I'll write here, cos 20, 20x. Okay, so this whole is actually this, the limits is for the whole expression. Right, now sine, this is sine 20, 20x upon sine 20, 22x. That will be written as 4 into 20, 22 minus 20, 20. Okay, into, I'm putting the limits now. 1 upon cos 0 plus 2 cos 0 plus cos 0. So this is 4 into 2 into 1 upon 1 plus 2 plus 1, that is equal to 4. So the answer to the question is 2. Hope you got that. Let's see with the option. Option B is the correct answer. Right. Let's move to the next question. Question number 67. If fx is equal to summation from p is equal to 1 to 7, p square sine inverse this whole term, then the value of df upon dx at x is equal to 1. You know this thing, sine inverse of sine x is equal to sine x. Of course, you know this. So I'll start with the sum. You are given fx is equal to summation p is equal to 1 to 7 p square sine inverse 4 by 5 sine px minus 3 by 5 cos px. So I'll say cos alpha is equal to 4 by 5. See, if cos alpha This is alpha. So cos alpha is 4 by 5. That means this side is 3, right? You will have sine alpha is 3 by 5, which gives you tan alpha as sine alpha upon cos alpha. That gives you 3 by 4. That's your tan alpha, right? I pick up this from here. You can see alpha is equal to tan inverse 3 by 4. Now I'll go with this one. Fx was equal to summation p is equal to 1 to 7 p square sine inverse cos alpha sine px minus sine alpha cos px. This is sine a cos b minus cos a sine b. So this is fx is equal to summation p is equal to 1 to 7 p square sine inverse sine px minus alpha, which makes summation p is equal to 1 to 7 sine inverse this will be equal to px minus alpha only. Further, let's open it up. You will have summation p is equal to 1 till 7 p cube x minus p square alpha. Let's open. So I'll take x outside. This is summation p is equal to 1 to 7 p cube minus alpha will come outside. Summation p is equal to 1 till 7 p square. The formula for sum of cubes till n cube, sum of cube of natural numbers is equal to n into n plus 1 upon 2 whole square, where n is the number of terms, and sum of squares of natural numbers is given by n into n plus 1 to n plus 1 whole divided by 6. So here you have to do the summation of the cubes of first 7 natural numbers. This will be x into 7 plus 1 whole divided by 2 square minus alpha into 7 into 7 plus 1 into 2, 7 plus 1 upon 6, which makes x into, this will be, see, this is 8, so this will be 4. So 28 square minus alpha into 7 into 8 into 15 upon 6. So you have this thing. That makes it 28 square is 784x minus 140 alpha. And what was alpha? It was, we calculated alpha over here. It was tan inverse 3 by 4. So that makes fx 784x minus 140 tan inverse 3 by 4. Now let's get to C1s, what we needed to find. df by dx at x is equal to 1. Okay, let's find out the derivative. So df upon dx is equal to, this will be 784 into 1 minus 140 into tan inverse. This is a constant, so this will be 0. Actually, this is 0 only. So that's it. 784. At x is equal to 1, there is no x term. So the answer to the question remains 784. That's it. Question option D. Hope you understood this question. Let's move to the next question now. Question number 68, given y is equal to ax plus b upon cx plus d, then dx upon dy is equal to. Okay, you are given y is equal to ax plus b upon cx plus d, and you have to find out dx upon dy. That means I have to make x the subject of formula in this case. So this can be written as y into cx plus d is equal to ax plus b, or y cx plus y into d minus b upon a. is equal to x. Okay, but I need this x also, so I'll have to rectify this. Note this step will come. You will write it down. Y c x plus y into d is equal to ax plus b, or y c x minus ax is equal to b minus yd. I'll take x common. So y into c minus a is equal to b minus y into d, or x will be written as b minus yd upon c into y minus a. Now I've made x a subject of the formula. Let's differentiate x with respect to y. Dx by dy is equal to, now this is square of the, here is a. So square of the denominator, numerator will have cy into a into the derivative of the numerator. So this is minus d minus b minus yd into c. That will be equal to minus c dy plus ad minus bc plus c dy whole divided by cy minus ca whole square. These two will cancel, and you will have ad minus bc upon a cy minus a whole square. This is the answer to the question. cy minus a is not there, but a minus cy square is there. This is one of the same thing. See, you can write the same thing as ad minus bc upon a minus cy whole square. So that simply is your option B. ad minus bc upon a minus cy whole square. Option B is the correct answer. Hope you got that. Next is question number 69. You are given x squared plus y square is equal to t minus 1 upon t, and x raised to power 4, y raised to power 4 is equal to t square plus 1 upon t square. Okay, so let's do squaring on the both sides. You have x raised to power 4 plus y raised to power 4 plus 2x square y square is equal to t square plus 1 upon t square minus 2. This thing is equal to t square plus 1 upon t square plus 2x square y square is equal to t square plus 1 upon t square minus 2. That makes x square y square is equal to minus 1. Now, what we have to find out, dy by dx. Let's differentiating both sides with respect to x. Differentiating both sides with respect to x. You will get first function into derivative of second plus second function into derivative of first is equal to 0. This will give you y dash is equal to minus 2xy square upon x square into 2y. 2 and 2 will cancel, 1x and 1y will cancel, and you will have minus y upon x. That's it, minus y upon x. This is the answer. Option D. Hope you got this. Next is question number 70. The equation of the tangent to this curve at the point 1, 10 is, given curve is x square plus y minus 7 is equal to 4x. If I write the curve in terms of y, you will write it as y is equal to minus x square plus 4x plus 7. On differentiating both sides with respect to x, both sides with respect to x, because we are given the equation of the tangent. That means we are interested in finding out the slope. So y dash is equal to minus 2x plus 4 plus 0, which gives you the slope. This is nothing but the slope. This is equal to minus 2x plus 4. Now, at point 1, 10, the slope is equal to minus 2 into 1 plus 4, that is equal to 2. So the slope comes out to be 2. You have to find out the equation of the tangent. The point is given to you and slope comes out to be, the point is 1, 10 and the slope is equal to 2. So equation of tangent will be y minus 10 is equal to 2 into x minus 1. Y minus 10 is equal to 2x minus 2, or that's it. Y is equal to 2x plus 8. Option A. Hope you understood. Then let's move to the next question. Question number 71. If theta is the angle between these two curves and tangent of theta is. Okay, so basically in the question, if I will find out theta, then I can find out tangent of theta also. So the first given curve is x square minus y square is equal to 4. And the second one, y square is equal to 3x. Let's differentiate both the sides. You will have 2x minus 2y, y dash is equal to 0, which gives you x is equal to y dash, or y dash is equal to x upon y, which actually is your slope also for the curve. Okay, this curves look something like this. This is the coordinate axis, minus 2 and 2. Right, let's go with the second curve now. So it is 2y, y dash is equal to 3, which gives you y dash is equal to 3 upon 2y, or slope for this curve is equal to 3 upon 2y. Let's differentiate them, saying m1 and m2. Okay, so now to get the point of intersection of both of these curves, point of intersection of these curves is, the first curve was x square minus sorry, it was the first one x. I'm taking this as terms of y. So this is x square minus 4 is equal to y square, and this one is y square is equal to 3x. So this can be written as x square minus 4 is equal to 3x. This becomes a quadratic. So 4x square plus x minus 4 is equal to 0. X minus 4 plus 1. X minus 4 is equal to 0. X plus 1. X minus 4 is equal to 0. These are the two factors. That means x will be either equal to 4 or minus 1. See, x is equal to minus 1. It can't be. Reason. You had the first curve as this, and the second one was this. If you're putting x is equal to minus 1, y comes out to be minus 3. Y square comes out to be minus 3. Square cannot be negative. Similarly, over here, this will be 1 minus 4 is equal to y square. So y square is minus 3, which is simply not possible. Square of a number cannot be negative. That means the only option is y is equal to 4. Okay, so now when y is equal to 4, sorry, x is equal to 4. When x is equal to 4, y comes out to be, y square was 3 into 4, that is 12, or y is equal to 2 root 3, plus minus. Okay. So the point at point 4 comma 2 root 3. Equations, slopes. M1 was equal to, it was x upon y, and m2 3 upon 2y. X upon y and m2 was 3 upon 2y. This was yes. So 4 upon 2 root 3, and m2 is equal to 3 into 2 root 3 and this. So m1 is equal to 2 upon root 3, and m2 is equal to this. Got both the slopes. Now I can easily find out tangent of theta. Tangent of theta is given by m1 minus m2 upon 1 plus m1 into m2. That's 2 upon root 3 minus root 3 upon 4, whole divided by 1 plus 2 upon root 3 multiply root 3 upon 4, like this. So this is equal to, the LCM will be 4 root 3 8 minus 3. This whole is divided by 1 plus 1 by 2, or that's equal to 3 by 2. Okay, so this is 5 upon this upon will go here. So this is 2 by 3. That becomes 5 upon 6 root 3. This is the answer to the question. You have to find out the tangent of theta. That is 5 upon 6 root 3, which is option B. Hope you understood this. Next is question number 72. The absolute maximum value of the function fx is equal to 2x cubed minus 3x squared minus 36x plus 9, defined at 3 comma minus 3, where x belongs to this. Now let's differentiating both sides with respect to x. You have f dash x is equal to 6x square minus 6x minus 36. Now for the putting f dash x is equal to 0 for critical numbers, you will have 6x square minus 6x minus 36 is equal to 0, or x square minus x minus 6 is equal to 0, which gives you x square minus 3x plus 2x minus 6 is equal to 0, x minus 3. So the two factors x plus 2, x minus 3 is equal to 0, which gives you x is equal to minus 2 and 3. So let's find out for the function at all the 3 digits, f3, f minus 2, and minus 3. So this is 2 into x cube, which is 3 cube, 2 into 3 cube, minus 3 into 3 square, minus 36 into 3 plus 9, which makes it 2 into 27, minus 27 minus 108 plus 9. So 54 minus 27 minus 108 plus 9 is minus 72. Okay. This becomes f of this. Here was minus 3 minus 2 square minus 36 minus 2 plus 9, which makes it, here was cube. Yeah. So that's 16 minus 16 and minus 12 plus 72 plus 9, that's 53. The last one, 2 into minus 3 cube minus 3 into minus 3 square minus 36 into minus 3 plus 9, which is equal to minus 54 minus 27 plus 108 plus 9, that is equal to 36. Okay, so looking at that, this is the minimum value and this one is the maximum value. And that means you had, in the question, you had to find out the absolute maximum value of this is 53, option B. Hope you got this. Let's move to the next question then. Question number 73, if fx is equal to this and f of pi by 4 is equal to 1, then f of 0 is equal to. So fx is the function which is integral of 2 minus 3 sine square x upon 1 plus cos 2x dx. So, okay, this can be written as integral of 2 minus 3 sine square x. 1 plus cos 2x can be written as 2 cos square x dx. Let's open it. So this will be 2 will cancel, secant square x minus 3 by 2 tangent square x dx. This is secant square x minus 2. Tan square x can be written as secant square x minus 1 dx. So this is secant square x minus 3 by 2. I will just write it down as secant square x minus 3 by 2. Secant square x will be minus 1 by 2. Secant square x plus 3 by 2 dx. Okay. Yeah. So now let's find out the integral. We have solved it completely. 1 by 2. Secant square is the derivative of tan x. So tan x plus 3 by 2x plus c. Right? You are given this is equal to fx. You are given f of pi by 4 is equal to 0. So this is 1 by 2 tan pi by 4 plus 3 by 2 pi by 4 plus c is equal to 0, which gives you minus 1 by 2 plus 3 pi by 8 plus c, which gives you c's value as, yeah. So c will be taken as, sorry, this is equal to 1, not 0. So 1 plus 1 by 2, this will be 3 by 2. I'll rewrite this. 3 by 2 minus 3 pi by 8 is equal to c, or c is equal to 3 by 8, 4 minus pi. Right. So now the equation fx becomes minus 1 by 2 tan x plus 3 by 2 x plus 3 by 8, 4 minus pi. You have to find out in the question f of 0. F of 0 is equal to minus 1 by 2 tangent of 0 plus 3 by 2 into 0 plus 3 by 8, 4 minus pi. Tangent of 0 is 0. So plus 0 plus this is 3 by 8, 4 minus pi. That's it. So the function at x is equal to 0 is 3 by 8, 4 minus pi. That's it. This is the answer to the question. Let's check with the options. This is the correct answer. Option A. Hope you got this. Next is question number 74. We are given x is not equal to 2n plus 1 pi by 2, where n belongs to the integers. Cos x is not equal to minus 1 by 2, then this whole expression is equal to. You are given, let this be I, is the integral of sine x plus sine 2x upon 1 plus cos x plus cos 2x dx. Let's open. You can write this as integral of sine x plus 2 sine x cos x whole divided by 1 plus cos x. Cos 2x can be written as 2 cos square x minus 1 into dx. So that's equal to, I'll take sine x common from here, 1 plus 2 cos x. There is a change. There was square over here. I missed that. Okay, so now this 1 and 1 will cancel. I'll take cos x common from here. I'll be left with 1 plus cos 2 cos x. Okay, they will cancel out dx, and you will have tan square x dx. Now tan square x dx can be written as secant square x minus 1 dx, which is integral of tan x minus x plus c. That's it. You needed to find out the value of this. So this is option D. Hope you got this. Next is question number 75. Given that integral of integral of 1 upon x squared plus a squared dx is equal to 1 by a tan inverse of x plus a, x divided by a plus c. If this integral is equal to this plus c tan inverse this plus k, where k is the constant of integration, then 5c plus d plus ab is all right. So first thing, I'll start from here. Integral of 1 upon x raised to power 4 plus 3x squared plus 1 dx is equal to 1 upon x square plus 1, dividing the numerator and the denominator with x square upon 1 plus x square dx. Here is 3. Okay, so this further can be written as 1 plus 1 upon x square minus 1 minus 1 upon x square. See, 2 will be introduced, so I'll divide I'll take 1 by 2 outside, and the denominator will remain same. X square plus 1 upon x square plus 3 into dx. So this further is equal to 1 by 2 integral of 1 upon 1 plus 1 upon x square plus 1 upon x square plus 3 minus integral of 1 . Question number 75. Before starting the question, students, here's a quick reminder to visit our website www.examsnet.com. To practice this paper and many more entrance exam question papers of the similar type, you have the PDF available there also. So you can also download our app. The link is available in the description box. Let's go with question number 75. You are given that the integral of 1 upon x square plus a square dx is equal to this, plus c, and integral of 1 upon x raised to power 4 plus 3x square plus 1 dx is equal to this, plus k, where k is the constant of integration. Then you have to find out this value. All right, I'll start with this portion. Integral of 1 upon x raised to power 4, 3x square plus 1 dx. Now, this can be dividing the numerator and the denominator with x square. You will have 1 upon x square is equal to 1 plus x square plus 3 plus 1 upon x square dx, which further can be written as integral of 1 plus 1 upon x square minus 1 minus 1 upon x square. See, this is 2 will be introduced over here, so I'll divide it with 1 by 2. Next, I'll keep this thing as such. This will be x square plus 1 upon x square plus 3 into dx. Further, you can write it as 1 by 2 integral of 1 plus 1 upon x square whole divided by 1x minus 1 upon x square plus root of 5 square. See, I have added and subtracted a 4 in this case, 2 in this case. So this will be x minus 1 upon x whole square plus root of 5 whole square minus integral of 1 minus 1 upon x square whole divided by x plus 1 upon x whole square plus 1 dx. Further, now I'll introduce root 5 dividing and multiplying with root 5. Why I have done this, you will just come to know. So you can write the integral of this is 1 upon root of 5 into tan inverse x minus 1 upon x upon root of 5 minus tan inverse x plus 1 upon x plus the constant k. Now, how did I arrive over here? Let's discuss that a bit. You know one thing, tan inverse x upon a is equal to a upon a square plus x squared derivative of tan inverse x upon a is equal to this, right? So here the x was x minus. Using this, you will write down derivative of tan inverse x minus 1 upon x is equal to a. In this case, a was root 5, right? So that means you will have a root 5 over here divided by root 5 square plus x minus 1 upon x square multiplied by derivative of this. And what is that? What is the derivative of this? This is root 5 square plus x minus 1 upon x square into x. This is x minus 1 upon x. That's 1 plus 1 upon x square. Okay, so using this, see, this is what we just did over here. This is the derivative of this term. All right, I hope you understood. So now let's solve it further. This will be written as 1 upon 2 root 5 tan inverse x square minus 1 upon root 5 into x minus 1 upon 2 tan inverse x square plus 1 upon x plus the constant k. You are given that this is equal to this. Let's compare both of them. This was equivalent to A tan inverse B x square minus 1 upon x plus C tan inverse D x square plus 1 upon x plus the constant k. Comparing both of them, you get the value of A as 1 by 2 root 5, B as 1 by root 5, C as minus 1 by 2, and D as 1. We have to find out the value of 5C plus D plus AB. Right. So let's fill in the values just. 5 minus 1 by 2 plus 1 plus 1 by 2 root 5 multiply by this. That's equal to 5 1 by 2 plus 1 by 10. That will give you 5 multiply 10, 6. So this will be 3. Okay. That is option A stands to be the correct answer. Hope you got this, right? Let's understand this once again. So I started from here. Then I divided the numerator and the denominator by x squared, splitting the numerator and the denominator. I did this like 1 by 2 into 1 plus 1 upon x squared minus 1 minus 1 upon x squared. So now I introduced this root 5 over here. So dividing the outside by 1 by root 5, and this will be multiplied. This is actually the derivative of tan inverse x minus 1 upon x upon root 5. And this one is the derivative of tan inverse x plus 1 upon x plus a. Now, I have just explained like how the derivative came out at this step. Now this when solving will give you 1 upon 2 root 5 tan inverse x squared minus 1 upon root 5x minus 1 by 2 tan inverse x squared plus 1 upon x plus k. Comparing it with the given equation, which was this. So according to that, this was the value of A, and the B was equal to 1 by root 5, and C is equal to minus 1 by 2. D is equal to 1 over here. Okay. So next you just have to find out 5C plus D plus AB. That's it. You got the value of the question as 3. Hope you understood this. Next is question number 76. Integral of, let's write down, integral of limit 0 to 4 mod of x minus 2 minus x dx. Now this mod, when I'll open it, can have two values, that's the negative and the positive. So this can be written as integral is equal to, this is 0 to 2. Now this can have the value of minus x minus 2 can have the minus x minus 2 minus x mod dx plus integral 2 to 4 x minus 2 minus x dx. Here this will cancel, and here you will have limits 0 to 2, 2 minus 2x dx plus 2 to 4 minus 2, 1 into dx. Okay. Now again, I'll split it because I'm having a mod over here. This will be written as 0 to 1 minus of, this will be, this will be 2 of 2 minus x dx plus 1 to 2 minus of 2 minus 2x dx plus minus 2 x limit 2 to 4. This will be 0 to 1. I'm finding the limits now. 2x minus 4x square upon 2 into 2. Limits are 0 to 1 minus of, this will be written as integral 2x minus 2, 0 to 1, limits 0 to 2, minus 4 minus 2. This will cancel out and you will have 2x minus x square, limit 0 to 1, minus 1 to 2, minus limit 0 to 1, minus, this will be x square minus 2x, 1 to 2, minus 4. So this will be 2 minus 1 minus 0 minus 0 minus 4 minus 4 minus 1 minus 2 minus 4 is equal to 1 minus, they will cancel, plus 3 minus 4, that is equal to 0. Question number 76, you have to find out the integral of limit 0 to 4 mod of x minus 2 mod minus x dx. Now, if I say this is some integral I, this integral I can be written as limits 0 to 2 mod of minus x minus 2 minus x dx plus limits 2 to 4 mod x minus 2 minus x dx. These will cancel and you will have your integral 0 to 2 mod of 2 minus 2x dx plus mod of integral, here is mod of minus 2 dx, which can further be written as, now I'll split it further, 0 to 1 mod, brackets 2 minus, this is for the positive value of the given expression and this is for the negative value. And 2 will come outside, you will have integral 1 dx limit 2 to 4. Further, now this, let's find out the integral. This will be 2x minus x square, limit 0 to 1 minus. So this one integral, I'll just write down first. This is 2x minus 2 dx plus 2x limits 2 to 4. This is 2 minus 1 minus 0 minus, and this integral is x square. Sorry, here was plus. Okay, this is x square minus 2x limits 1 to 2 plus 2, 4 minus 2. That's equal to 1 plus 4 minus 4. Then plus 2 minus 1. Plus 2 into 2. That's 1 plus 4. These will cancel. Plus 1, which is 6. So 6 is the answer to the question. That is option C. Hope you got that. Let's move to the next question then. Question number 77. If integral of limits minus a to a fx dx is equal to limit 0 to a fx dx plus limit 0 to a gx dx, then gx is equal to, you're given this statement. And we know one thing, when you have the limits from minus a to a fx dx, this can be written as minus a to 0 fx dx plus 0 to a, fx dx, right? So now let's say I'm using, see, this can be written as limit 0 to a fx dx plus minus a to 0 fx dx. So this matches, these two match. I'll just forget about this for some time and I'll use this one only. Now let's put in the second one, second term, put x is equal to minus t. That will give you dx is equal to minus dt. Also, when x is approaching 0, t will approach 0, and when x is giving approaching minus a, t will approach a. So the limits, this limits will change to, this will remain as such. I'll not touch this one. So this will become limits a to 0 f of minus t into minus dt, 0 to a fx dx minus a to 0 this, right? Yeah. So I'll change the limits now. Plus 0 to a f of minus t dt, f of minus t was equal to fx and dt is minus dx. So that's equal to 0 to a fx dx minus 0 to a fx dx. Now let's compare it with the given one. You were given that this is equal to limit 0 to a fx dx plus, sorry, okay, plus gx dx, limits 0 to a. So on comparing both of them, you simply get that gx is equal to minus of f of x. That's it, right? So let's check with the option minus f of x. This is option A. Hope you got the problem. Next is question number 78. F of x, y, c1, c2 is equal to 0 is an equation containing two arbitrary constants, c1, c2. If the differential equation having this is equal to 0 as its general solution is of the kth order, then the differential equation corresponding to this is. So now you're given this thing first. X raised to power k plus y raised to power k is equal to c square. Since you are having two constants, c1, c2, so that means here k is it's of the kth order, so that means k is equal to 2, which gives you x square plus y square is equal to c square. Let's find out the derivative with respect to x. So 2x plus 2y dy by dx is equal to 0. That gives you x plus, I'll divide both the sides with 2, x plus y dy by dx is equal to 0, or dy by dx, dividing both the sides by y. Okay, so if I divide both sides by y, you have dy by dx plus xy, x upon y is equal to 0. This is answer to the question. Let's check. Dy by dx plus x upon y. This is option A. So option A is the correct answer. Next is question number 79. Let L and M respectively are the order and the degree of this differential equation whose general solution is this. Then Fm plus Gm is equal to. So first thing here in the question, if I'm talking about M, what is M? It is 1. That is degree of this differential equation. Right? It is a second order and first degree differential equation. Now you are given that y is equal to a x square plus b log of x or y upon x square. Dividing both sides by x square will be given by b, okay, is equal to a plus b log of x. Question number 79. If L and M respectively are the order and the degree of this differential equation, whose general solution is given by this, then Fm plus Gm is equal to. Here's a slight modification. The question has Bx square log x. Now in the question, the given differential equation is y is equal to ax square plus bx square log x. This can be written as y upon x square is equal to a plus b log of x, right? Now differentiating both sides with respect to x. You will get this one as 1 upon x square y dash minus 2 upon x cube y is equal to b upon x, which will give you, let's divide both the sides by x. You will have 1 by x y dash 2 by x square y is equal to b. Again differentiating both sides by with respect to x. Differentiating both sides with respect to x, you will have 1 by x, second derivative of y minus first derivative upon x square plus 4y upon x cube 2 upon x square y dash is equal to 0, which will give you on solving minus 1 by x y double dash plus 3y dash upon x square is equal to 4y upon x cube. 4y upon x. It's x cube only. Okay, minus 1 upon x, y double dash plus 3y dash upon x square is equal to 4y upon x cube. Now let's divide both the sides by x square. You will have multiply both the sides by x square. You will have minus xy double dash plus 3y dash is equal to 4y upon x. Now on comparing it with this given differential equation, this is equivalent to fx y double dash plus g x y dash is equal to 4y upon x. Now on comparing, you get fx is equal to minus x and gx is equal to 3. You have to find out fm plus gm, where L is the order of this differential equation. What is the order of differential equation? It's a second order derivative equation. So order is 2 and degree is 1. Its pi power is 1, so degree is equal to 1. That means here you have L is equal to 2 and M is equal to 1. Basically, you have to find out Fm, that is equal to minus 1, and Gm, that will remain 3 only. Correct. You have to find the summation of 2. Fm plus Gm, that will be 2. Okay, this is nothing but the order of this equation. Differential equation, option B is the correct answer. Hope you got that. So let's move to the last question of this paper, question number 80. Here we go. The general solution of this differential equation is simple as that. Very simple question. You have to find out the general solution of it. And here, dx is equal to 2x plus 3y minus 4 dy. Dx upon dy can be written as 2x plus 3y minus 4. Let's put this is equal to some z. So dx upon dy is equal to z, right? Okay. Also, I'll pick up this one now. 2x plus 3y minus 4z is equal to z. Let's find out the derivative with respect to y. Dx upon dy plus 3 minus 0 is equal to dz upon dy. I'm finding the derivative with respect to y. So here dx upon dy is equal to 1 by 2 dz upon dy minus 3 by 2. Now, 1 by 2 dz upon dy minus 3 by 2, this is equal to z, right? Over here, we said this is equal to z. That becomes equal to z, right? So dz upon dy is equal to 2z plus 3 or dz is equal to, okay, dz is, I'll take this down. So 2z plus 3 is equal to dy. Now let's find out the integral on both the sides. Okay, so this is equal to 1 by 2 log of 2z plus 3 plus the constant y is equal to c. That is log of 4x. What was z? It was, let's write down, z was equal to 2x plus 3y minus 4. So this becomes 4x plus 6y minus 8 plus 3 plus 2 c1 is equal to 2y, which is 6y minus 3 log 4x plus 6y minus 5 is equal to 6c1. That gives you 6y minus 3 log 4x plus 6y minus 5 is equal to some c. This 6c1, this is the constant. I'm writing this as c. So let's check with the options. Which is the correct option for this? Option B. So option B is the correct answer for the question. So students, with this, we have completed all the 80 questions of this paper. I hope you understood them well. If you have any doubts, then you can put your suggestions in the comment box. Also, a very best of luck for your exams. Keep shining, keep rising high. Best of luck for this exam. Bye.